So let's begin with the motion in a straight line. So let's start with an example. Suppose it's early morning and this is me, this is my home, and there is this straight road in front of my home. Okay, and suppose that I wake up in the morning, I do certain things and I go for jogging, right? So I go along this way, along a straight line. Then there is this newspaper shop. I purchase a newspaper. Then again I keep on jogging, and there is this tea shop, my favorite tea shop. Okay, not a good thing to do in the morning after you jog, but suppose I take tea there and I read newspaper, and then I come back, okay, and I stop over here. So now here are certain quantities to be described. So first is the distance covered. What is the distance covered in this path or in this journey? So suppose this distance from A to B is 5 kilometers, this distance is 3 kilometers. How much would be the distance covered? It is 5 plus 3 plus 3 plus 5, right? 16. Okay, 16 kilometers. That's too much, right? It won't be that much. Anyways, so suppose it is 16 kilometers, just for an example. Then, okay, nobody will jog for 16 kilometers. Okay. So let's suppose this is 500 meters, this is 300 meters. That is a good estimate. 500 meters, 300 meters. Okay. So this will be 800 meters along, I mean, one way it's 800 meters and one way it is 800 meters. So in round trip, the total distance covered would be what? Yeah, 1.6 kilometers. That is good. All right. So then, now how much would be the displacement? So distance is just the total length of the path covered, right? So it is 1.6 kilometers, right? 1600 meters. And displacement is the shortest distance between start point and end point of the motion. So what is the start point? A is the start point. What is the end point? A is the end point. So how much is the displacement here? Displacement is 0. No, displacement would be 0, no? If I start from A, I come back to A, displacement would be 0, right? Okay, good. Then, so this is displacement. Displacement would be equal to 0. After that, suppose I start from A, go to this point C, come back, and that I give that newspaper back to the newspaper shop. Suppose I just have monthly subscription and I don't buy it. Okay, I just take it just for the sake of reading. Then these things are immaterial. I go till here and come back till here. Then how much would be the distance covered and how much would be the displacement? How much would be the distance covered? How much would be the displacement? Yeah, so distance covered would be equal to 1.1 kilometer. Good. And displacement would be equal to 500 meters, right? Because this distance is 500 meters. Yeah, very good. Yamini, Porna, very good. So this much is the displacement, just distance between the start point and end point, and the total length of the path is the distance. So that is 800 plus 300, that means 1100 meters, that is 1.1 kilometers, right? Then we define a few more terms. So one is average speed. What is average speed? It is the distance covered divided by time. Average speed is what? Distance covered divided by time. And next is average velocity. It is just the displacement divided by time. Okay, so average speed, distance covered upon time, average velocity, displacement divided by time, right? So now you must have noticed one thing, that the distance covered is almost always greater than the displacement. Okay, so suppose I start from here, I go till here. Then if I keep on walking along the same straight line and I never turn back, then the distance and displacement would be equal. Okay, but otherwise it will be always, the distance will be always greater than the displacement, right? So distance, so S is suppose displacement, d is the distance, so distance is always greater than displacement, okay? And that means if I denote average speed by u and average velocity by v, then average velocity will be always less than the average speed, okay? It's less than or equal to, it's equal to in only one case, when I start and keep on walking along the same straight line and I don't turn back, right? Then speed and velocity are equal. This thing is clear? Okay, very good. Then let's come to the types of motion. So there are two types of motion. One is the uniform motion, one is non-uniform motion. What is uniform motion? The motion in which velocity remains constant. It is known as the uniform motion. And what is non-uniform motion? The motion in which velocity changes. It's called as non-uniform motion, right? So then we define another term. Okay, all of these terms I think you know them. So next is the average acceleration. So suppose for an example, I start with velocity v1 and I end up with velocity v2. So v1 is velocity at time t1, v2 is the velocity at time t2. Then what is the acceleration? What is the average acceleration? Average acceleration would be equal to what? The final velocity minus initial velocity divided by final time minus initial time. Okay, v2 minus v1 divided by t2 minus t1. Right, it's very straightforward. Okay, and then we define a type of motion called as uniformly accelerated motion. Uniform motion means velocity remains constant, uniform acceleration. So the meaning is clear, right? It's uniformly accelerated means the acceleration is constant. Okay, so this is motion of a body with constant acceleration. Okay, motion of a body with constant acceleration is called as uniformly accelerated motion. Very, very simple. Okay, so for this kind of motion, again, u is suppose the initial velocity, v is the final velocity, and acceleration is constant. So now we are not finding out the average acceleration, this is constant acceleration. Okay, so a is still equal to final velocity minus initial velocity divided by time, v minus u divided by t. And if you take this t on this side, okay, you get at equals to v minus u or v equals to u plus at. So this is an equation, it's followed by a body which is moving with uniform acceleration, okay, which is doing uniformly accelerated motion. So that body follows this equation. This is called as the first kinematic equation. Okay, there are three kinematic equations. So this is first kinematic equation, v is equal to u plus at. The final velocity is equal to initial velocity plus acceleration into time, right? So this thing is clear?
Yes, sir.
Okay, very good. So then, all right, then we'll talk about the other kinematic equations, but before that, just based upon this thing, let's try to solve some problems. Okay, so let's see this one. So we are studying motion in a straight line. Find the velocity, average velocity when particle complete circle of radius 1 meter in 10 seconds. So now, is this along a straight line? Of course it is not. Right, this motion is not along a straight line, but the concept of the speed and velocity, it's applicable here, right? Distance, displacement, speed and velocity, they are applicable everywhere. Okay, so this is basic thing. Find the average velocity when particle complete the circle of radius 1 meter in 10 seconds. So tell me, who will tell me? So option D, Yamini says option D. Everybody else is convinced, or do you think otherwise? It's not option D. Is it option D? Okay, very good. Right, so you know that. So when the particle completes one circle, the displacement is 0. That means velocity would be equal to 0, right? Average velocity would be equal to 0. Okay, V average would be equal to what? The displacement divided by time. So displacement is 0 when particle starts from A, comes back to A, and therefore average velocity would be equal to 0. Good. Then let us see next one. A runner starts from O and goes to O following the path OQRO in 1 hour. What is the net displacement and average speed? Tell me. Yes. Anybody? So runner starts from O and goes to O. What is the displacement? Displacement is 0. Starts from O and goes to O. So displacement is 0. So it's 0 in all of the options. So that's not what we want to find out. What's the average speed is the question. It's option C. Okay, let's check. Alright, good. Everybody is saying option C. Right. So he goes from O to Q, Q to R, and R to O. Okay. So total circumference is equal to what? 2 pi R. This is 1/4 of the circumference, right? So the distance covered is equal to what? O to Q plus Q to R plus R to O. So that is equal to, I can say, radius plus this is 2 pi R divided by 4, right? This is 1/4 of the circumference plus radius. R to O is also radius. That is equal to 2R, and 2 you can take common, so it's 2 times R plus what? Pi by 4. Right? Or let's keep it like this, 2R plus pi by 2. Sorry, pi R by 2. Then we can put what is R. What is R? R is 1 kilometer. So, and all of the options are in kilometers per hour. So put R equals to 1 kilometer. So D is equal to what? 2 plus pi is 3.14 divided by 2. So 3.14 divided by 2 is 1.57. So 2 plus 1.57 is equal to 3.57. This is distance covered. Time taken is 1 hour. Okay. So the speed is equal to distance by time, that is 3.57 in 1 hour. So it's option A, no? Right? Okay, good. So it's not option C, option A. Alright, so this was very, very simple, right? Very simple question. Let's see next one. A wheel completes 2000 revolutions to cover the 9.5 kilometer distance. Then the diameter of wheel is. Tell me. A wheel completes. This is a wheel and it completes. It's going along a straight line, suppose. Like this. Okay. So when it completes one revolution, what will happen? So suppose it starts from this point. Okay. The wheel rolls, right? So it completes one revolution to go from A to B. So how much would be the distance from A to B? Anyone? So if it covers one revolution, means it will start from this point. Next, what will happen? If it rolls, then this point will come in contact. Yeah, it's equal to circumference, right? The next point will come in contact. The next point will come in contact. So if it revolves, okay, through one circle, then that means this point A, the same point of body will come in contact over here. right? At point B also. So this much distance is equal to 2 pi r. Then it's very simple. So it completes 2000 revolutions to cover a distance of 9.5 kilometers. So you can say number of revolutions, n is suppose the number of revolutions. Let's check. Okay, number of revolutions. So n times 2 pi r is equal to what? 9.5 kilometers. But the options are given in meters. So let's convert this to 9500 meters, right? So n is 2000. So this is 2000 multiplied by 2 pi r. So pi is 3.14 and r is what? That's what we want to find out. Okay, or let's write it's pi d. So 3.14 multiplied by d is diameter. Okay, d is equal to 2r. D is equal to 2r. So then if we divide by this thing, what do we get? So this 9500 divided by 2000 will be 4.75, right? So you have d equal to 4.75 divided by 3.14. So it's nearly 1.5. Somebody said 1.5. 1.5 meters is the answer.
Sir.
Yeah, tell me. It's incorrect.
Sir, once show previous question, sir.
Previous question. This one?
Yes, sir.
Yeah.
Okay, sir.
No problem, no?
No, sir.
Okay. All right. Then let's see next one. A cyclist moving on a circular track of radius 40 meters completes half revolution in 40 seconds. Its average velocity is, okay, tell me, it completes half revolution in, so half revolution in 40 seconds. How much is the radius? Option B you are saying, Yamini. Okay, let's check. So radius is equal to 40. This is given. Tell me, others? Anyone? All right. So when it covers half revolution, what will happen? What will be the distance covered? Distance covered is pi r. Okay, for full revolution it will be 2 pi r. For half revolution it is pi r. Then what's the displacement? So the object goes from this point to this point. So what is the straight line distance? What's the displacement? It is just 2r, right? So displacement it's equal to 2r, okay, and therefore velocity is equal to what? 2r divided by time. That is 2 times r is 40 and in 40 seconds, so that means 2 meters per second. Yeah, so it's option B. Very good. So question is simple, right? Okay, good. Then let's see one thing, the conversion from kilometer per hour to meter per second. Okay, so conversion from kilometer per hour to meter per second. So 1 kilometer per hour is equal to what? Let's convert it, right? 1 kilometer is 1000 meters. It's 1000 meters. and 1 hour is 60 minutes, and each 60 minute has 60 seconds, so it is 3600 seconds. So if you divide this, okay, what will happen? So it's 10 by 36, or you can say it's 5 by 18. So 5 by 18 meters per second. Okay, so we need to remember this thing. Whenever we want to convert speed from kilometer per hour to meters per second, we'll multiply by 5 by 18. And if we want to convert from meters per second to kilometer per hour, it will be multiplied by 18 by 5. Okay, a simple thing, right? Okay, good. Then now let's see this problem. A car covers first half of the distance between two places at 40 kilometers per hour and another half at 60 kilometers per hour. The average speed of the car is. So now let me explain the solution of this, and this kind of problem is repeated. Okay, so let's discuss this. A car covers first half of the distance. So first half, so total distance is, suppose this is the car, it goes from A to C. Total distance is suppose S. So first half would be equal to S by 2. Next half would be also equal to S by 2. So distance AB is S by 2. Distance BC is also S by 2. Right? Then now we want to find out average speed of the car. What is average speed? It is just total distance covered divided by total time taken. Okay. Of course, we know what is the total distance covered, right? Total distance covered we know, it's S. But do we know total time taken? We don't know, right? I mean, if S is total distance covered and V is some velocity, we can find out the time, right? So suppose it covers this half distance with speed V1. How can I say what can I say? V1 would be equal to what? S1 divided by T1. The distance covered divided by time is T1. Okay, and V2 would be equal to the speed from B to C. It's equal to the distance covered, that's S2 divided by time is T2. Okay, what would be the average speed? V average would be equal to what? Total distance, that is S, divided by total time is time from here to here. Time to go from here to here is T1. Time to go from here to here is T2. So total time is T1 plus T2, right? Then this thing, what is S1? S1 is also S by 2. S2 is also S by 2. So this thing will be S by 2 T1. This is S by 2 T1 and this is S by 2. Sorry, from here I will find out T1 and T2. T1 will be equal to what? S by 2 V1. Okay, if I take this T on this side, V on this side, so T1 will be equal to S1 by V1, but S1 is equal to S by 2. So T1 would be equal to what? S by 2 V1. And similarly T2 would be equal to S by 2 V2. I substitute that for T1 and T2. And then I can cancel out S in the numerator and denominator. Okay, so this is V average is 1 upon 1 by 2 V1 plus 1 by 2 V2. If I take reciprocal of this, what will I get? If I take reciprocal of this thing, see, I got V average is 1 upon 2 V1 plus 1 upon 2 V2, right? 1 upon 2 V1 plus 1 upon 2 V2. That's what I got. Okay, and if I take reciprocal of that, what will I get? 1 upon V average is equal to 1 by 2 V1 plus 1 by 2 V2. This is what we get. Okay, 1 upon V average is equal to 1 by 2 V1 plus 1 by 2 V2. Right, this thing is clear, everyone? Okay, so now we need to remember this formula. If body covers a certain distance, let's say distance S, so first half it covers with velocity V1, next half it covers with velocity V2, then what's the relation of average velocity with those two velocities? So 1 upon V average is equal to 1 upon 2 V1 plus 1 upon 2 V2, right? we need to remember this one. Okay, and for the sake of this problem, we'll simplify this. So what would be V average then? It's you can take this 2 which is in denominator of denominator to the numerator, and you simplify this thing. Okay, so you do cross multiplication, you write V2 here, V1 here, and in denominator you will have V1 V2, so that 2 times V1 V2 comes to the numerator. So the average speed becomes what? 2 times V1 V2 divided by V1 plus V2. Okay, it becomes 2 times V1 V2 divided by V1 plus V2. So for two bodies, remember it in this form as well as in this form. This thing is clear? Yes, no? Okay, very good. Then what is the first speed? That is V1, it's 40, and V2 is 60. So just put that over here. So average speed would be what? 2 times V1 V2. Okay, that's 60 times 40 divided by V1 plus V2. So 60 plus 40, that's 100. Okay, and then the answer that you get is, when you solve this, you will get 48 kilometers per hour. That's the answer. 48 kilometers per hour. It's option B. Okay, so this problem is very well understood, right, by everybody. Okay, so now let's see some problems which are like this. So a person traveling in a straight line moves with a constant velocity v1 for certain distance x and with constant velocity v2 for next equal distance. Okay, so you can say s by 2, s by 2. The average velocity v is given by the relation. Tell me, a, b, c, d. Yeah, it's option B. Very good. Okay, so we saw this thing. 1 upon V average would be equal to what? 1 upon 2 V1 plus 1 upon 2 V2. Take this 2 on this side, right? You can take 2 common from these two terms and move it over here. So this thing can be written as 2 upon V average is equal to 1 by V1 plus 1 by V2. Okay, very good. Very good, Yamini. So this thing is clear, everyone? Right. Then next, so now if the path is divided into n equal parts, okay, not just 2, the total path, the distance s is divided in n equal parts. Okay, and the body covers these distances, that is s1, s2, okay, which will be equal to s by n because you are dividing it into n equal parts with velocities v1, v2, v3, so on and so forth up to vn. Then you can write that n upon v average, okay, n upon v average is equal to 1 by v1 plus 1 by v2 plus 1 by v3, so on and so forth up to 1 upon vn. This is clear? Okay, we can extend the same formula, right? So remember this thing. So those two velocities is just special case of this thing. Okay, now let's see another problem. This is from NEET 2023 only. A simple problem. A vehicle travels half the distance with speed v and remaining distance with speed 2v. Its average speed is, you tell me. So you have option C. Okay, let's check. So 2 upon v average can be written as what? 1 upon v1 plus 1 upon v2, right? So that's equal to, or you could just use this formula, no? It's two body problem. So for, not two body, two velocities problem. So v average is just equal to what? 2 times v1 v2 divided by v1 plus v2. So that is equal to 2 times of v1 is what? V. v2 is 2v, and in denominator you will have v1, which is v plus 2v, right? So this will be 4v square divided by 3v, and that is equal to 4 by 3v. Good. So that's the answer, 4 by 3v. So this is clear. It's very simple, right? Okay, good. All right, then let's see this one. A car moves from x to y with uniform speed vu and returns to x with uniform speed vd. The average speed for this round trip is. So again, this is repeated problem, right? So its answer is option A, 2 times vd into vu divided by vd plus vu. Okay, so then let's see this another case. Now see, they can ask question like this. The body covers first half distance, okay, or let's suppose first 1/3 distance with speed v1, next 1/3 with speed v2, next 1/3 with speed v3. Okay, then you know how to solve that, right? Then 3 divided by v average would be equal to what? 1 upon v1 plus 1 upon v2 plus 1 upon v3. But now there is nothing which will stop them to ask a question like this. Suppose a car moves along a path of length s. First 1/3 of the distance is covered with velocity v1 and remaining with velocity v2. Find the average velocity. Then what will you do? So the trick is you can still apply the same formula. Okay, so as I said, it will be 3 divided by v average is 1 upon v1 plus 1 upon v2 plus 1 upon v3. So what I did is, this total distance is s. First 1/3 is covered with velocity v1, next 2/3 is covered with velocity v2. So what does that mean? So if you divide this distance in 2 equal parts, this much is covered, okay, this much is covered with speed what? v2, and this much is also covered with speed v2 only. So your v3 is also equal to v2, right? So that's the trick. So you can write 3 divided by v average is equal to 1 upon v1, okay, plus 1 upon v2 plus 1 upon v3, but v3 is also equal to what? v2 only. And then you can simplify this, okay? So this thing will be 2 divided by v2, and you can simplify this then. So it will be v2 plus 2 times of v1 if you do cross multiplication divided by v1 v2, okay, and then you can take its reciprocal and move this 3 on this side. So v average will be equal to 3 times v1 v2 divided by v2 plus 2 v1. This is clear, everyone? Okay, so now you don't remember this answer, you should be able to solve any problem which fits in this format, right? So they can say that a body covers certain distance, okay, so first 2/5 is covered with velocity v1, next 3/5 is covered with velocity v2. Then what can you do? You can divide, you can chop that distance into 5 equal parts, right? So v1 and v2 will be equal to v1 only, v3, v4, 5 will be equal to v2. So are you getting this, everyone?
Yes, sir.
Right, good. So you should be able to solve any kind of problem which fits in this format, okay? All right, then let's move on to the next topic. Next topic is uniformly accelerated motion. So now suppose I just want to plot the graph. We'll come to graph plotting or graphs for motion We'll see that in detail, okay, in maybe in next lecture. But for now, suppose I want to plot the velocity versus time graph for the uniform motion. So in uniform motion, the velocity is constant, right? The velocity is constant. So this graph will be a straight line. It will be just a horizontal line, right? It's parallel to time axis. So here velocity is constant. In uniformly accelerated motion, the acceleration is constant. So velocity keeps on increasing uniformly. So again, this graph will also be a straight line, okay, but it will have some slope, right? It has some slope. And how to find that slope? So see, on velocity axis, on this vertical axis, this is suppose the initial velocity v0, this is velocity at some time t. So vt minus v0 will be what? It is the change in velocity, and this is the distance covered, or yeah, this distance on the time axis, it's what? It's the time, right? It's the time taken. So this much change on the vertical axis, it is change in velocity divided by this is change in time. So if you take ratio of that, you will get what? You will get acceleration. Change in velocity divided by change in time, you get acceleration, and that is the slope of this curve. Okay, that is the slope of this curve, right? This thing is clear? Okay, so this is the curve for uniformly accelerated motion. Okay, so the acceleration can be found by Vt minus V0 divided by the time, right? And then we can do certain things using the slope. We can find out acceleration. Then using the area under the curve, we can find out displacement. But we are not going to do all of that. Okay, what we are going to do is we'll just take these three equations which we already know. Okay, so body which is in constant acceleration will follow these equations, right? So these are known as kinematic equations. Okay, what are kinematic equations? So the body moving with constant acceleration follows kinematic equations. There are these three kinematic equations. V is equal to u plus at, s is equal to ut plus half of at square, and v square is equal to u square plus 2as. And in addition to that, I will write one more equation. Okay, these three are known as kinematic equations. If you want to find out average velocity of the body moving in uniform acceleration, the average velocity is just equal to V average is u plus v divided by 2. Okay, very simple relation. Average velocity is just equal to what? U plus v divided by 2. Okay, this thing is clear? Yeah. So any example of uniformly accelerated motion? Can you think of any example? Okay, an object thrown upwards suppose, or an object which is released from some height or thrown downwards from some height. That is the object which is moving just under the force of gravity. It is a uniformly accelerated motion. Okay, object moving vertically in vertical direction just under the force of gravity, right? So an example is object moving in vertical direction under gravity. Okay, so let's consider specific case of that, which is known as free fall, right? So suppose you have this ball which is released from some height, it's released from this height and it's just falling. Okay, you have just released it, so it's falling under the gravity. So what is the acceleration acting on it? Here acceleration is equal to, now see, ball is moving in this direction, right? Ball is moving downwards and acceleration is also downwards. So we'll take acceleration as positive. So A is equal to G. Okay, A is equal to G. And initial velocity is equal to what? It's 0. Then for this ball, what can you say? Final velocity will be just equal to GT, right? At some time, final velocity V will be equal to GT because U is 0. Okay, what will be S? What will be the distance covered? So S is equal to UT. So U is 0. So that is just half of GT square. Okay, and what about V square? V square will be just equal to 2 times G into S. And V square is just equal to 2 times GS. Right? So these will be 3 equations followed by this ball or any object which is released, freely released under the gravity. This thing is clear, everyone? Okay, right. So here you have released a ball or an object and it's falling down. So it's moving downwards, acceleration is also downwards. So we took acceleration as positive because the motion and the acceleration, they are in same direction. Now suppose you are throwing the ball upwards. Okay, you throw the ball upwards, then what will happen? Tell me. An object is thrown upwards. An object is thrown upwards. Okay, then you can say its V will be equal to, see, V will be the final speed, U is some initial speed, right? So you can say V will be equal to U minus GT. Why minus G? Because it is moving upwards, acceleration is downwards, right? They are in opposite direction. So V is equal to U minus GT. Then the distance covered. So here the displacement, will say it is the height. The height is equal to H would be equal to UT minus half of GT square. Okay, and next one is V square is equal to U square minus 2G, and the distance covered, we'll call it height. Okay, V square is equal to U square minus 2GH. This thing is clear, everyone? Right? Because the reason for this is motion and acceleration are opposite, are in opposite direction. Okay, therefore A is taken as minus G. That's it. It's very simple. Okay, and then there is one more thing which is very helpful, very helpful. So Galileo, who is also called as father of physics, okay, so he made a law, made means he discovered a law, that for any object which is moving in uniform, which is moving with uniform acceleration, the distances covered in times t1, t2, t3, if these times are equal, okay, by a body performing uniformly accelerated motion, are in the ratio of 1:3:5 if t1, t2, t3 are equal. Okay, the distances covered in equal times T1, T2, T3 are in the ratio of 1:3:5. So this is called as the Galileo's law of odd numbers. For an example, you release a ball, okay? You release a ball from some height. So distance covered in time T1 is suppose S1, then distance covered in time T2 when T1 and T2 are equal, right? All these times are equal. So the distances covered are in the ratio of 1:3:5:7. Okay, 1:3:5:7 and so on and so forth. This thing is clear. This is known as the Galileo's law of odd numbers and it will be very helpful. Alright, so then this is from NEET 2022. The ratio of distances travelled by a freely falling body in the first, second, third and fourth second. Tell me. It's a direct question. It's option B. Good. Okay. Right, very good. It's option B. This is direct question based on the Galileo's law of odd numbers. Alright. Then, so this is true for any uniformly accelerated motion, not just gravity, okay? Alright, let's discuss some questions based upon uniformly accelerated motion. A ball is thrown vertically downward with a velocity of 20 meters per second from top of a tower. It hits the ground after some time with velocity 80 meters per second. The height of the tower is, tell me. Anyone? Okay, what will you do? It's option D, 300 meters. Let's check. What did you do? How did you solve? Yeah, very good. V square minus U square is 2as. Okay, so you have ball thrown downwards with initial velocity 20 meters per second and it hits the ground after some time with velocity of 80 meters per second, right? So U is equal to 20 meters per second, that's given. V is equal to what? 80 meters per second. Okay, and we want to find out the height. So you have V square minus U square is equal to 2as or 2ah we can say, because it hits the ground, and therefore h is equal to V square minus U square divided by 2a. Okay, a is equal to g, right, because it is thrown downwards. So V square minus U square can be written as V minus U, V plus U, and in denominator you have 2a. Then I will substitute values. So V is equal to what? It is equal to 80. It is equal to 80 minus 20 multiplied by 80 plus 20 divided by 2 times of 10. So 80 minus 20 is 60. 60 times it's 100. Okay, 100 divided by 10 is 10. So that is 600 divided by 2. That's 300. So h is equal to 300 meters. This is the answer. Okay, this is very, very simple, right? Okay, then let's see next one. A stone falls freely under gravity. It covers distances h1, h2, h3 in first 5 seconds, the next 5 seconds and the next 5 seconds respectively. The relation between h1, h2, h3 is, tell me. Again, this is based on the Galileo's law of odd numbers. It is option D. Yeah, it's option D. Good. Everybody? All right, let me solve it. So you have H1 is to H2 is to H3 is 1 is to 3 is to 5, right? So if you want H1 is to H2, that's 1 by 3, okay? So therefore, if you take H2 on this side, you will get H1 is equal to H2 by 3, right? Similarly, H1 is to H3 will be equal to what? 1 is to 5, right? So it's 1 is to 5, and therefore H1 is equal to, you take H3 on this side, okay? So H3 divided by 5, and therefore you can write sorry, H1 is to H2 is to H3, or H1 is equal to what? H2 by 3, it's H3 by 5, right? That's option D. This is clear, everyone? Okay, good. That's very simple, right? Because we know the law. Otherwise you try it. Don't use the law and try it. Okay, how much time does it take? So Galileo has made our life simple, right? All right, let's see next question. A boy standing at the top of a tower of 20-meter height drops a stone. Assuming g equals to 10 meters per second square, the velocity with which it hits the ground is? Tell me.
20 meter per second.
20 meters per second.
Yes, sir.
All right, let's check. The boy just drops the stone, no? Okay, so h is equal to, okay, what will you use? The velocity at which it hits the ground. Yeah, v square is equal to 2 times g into h, because u will be equal to 0 when he just drops the stone, or v is just equal to, you can say, root 2 gh. Now you should remember this formula. V is equal to root 2 gh. Okay, if some object is just dropped from some height and it hits the ground with velocity v, then what will be that velocity? It's just equal to root 2 gh. Okay, directly remember this formula, no need to apply v square minus u square etc. Just remember this one, v is equal to root 2 gh. So that's equal to square root of 2 times of g is 10, 10 multiplied by height is 20. Yeah, so that's 20 times 20. Okay, so v is equal to 20 meters per second. Very good. So very simple problem, right? Okay, good. Then let's see next one. A particle starts its motion from rest under the action of constant force. Constant force means constant acceleration. Okay, so we know that force is equal to mass into acceleration. So if force is constant, means acceleration is constant. Okay, if the distance covered in first 10 seconds is s1, that covered in the first 20 seconds is s2, then now you tell me. Everyone. So option B, S2 is equal to 4 times of S1. Everyone? Okay, so let me explain. So ball is dropped, right, and in first 10 seconds it goes till here. Okay, in first 10 seconds it goes till here. So let's call this height h1. H1 is equal to what? H1 will be equal to S1. Okay, this is in first 10 seconds in time t1. Then in first 20 seconds it goes till some height, sorry, it covers some distance. So let's suppose h1 is this one and h2 is this one. H2 will be equal to what? So you know this is covered in next t1 seconds or next t seconds. So then this is equal to what? 3 times of s1. Okay, so they say that the distance covered, so let's say this is in 10 seconds and this is in next 10 seconds, in next 10 seconds. Okay, so first one is suppose h1 and next is suppose h2. So h2 will be equal to 3 times of h1, that is 3 times of s1, that you know. So they are saying the distance covered in first 20 seconds is equal to s2. So this total distance is equal to s2. Okay, this total distance is equal to what? S2. So how much is S2? S1 plus 3S1 means 4S1. Right? Okay, this is simple. Selva Kumar. Okay, very good. Then let's see next one. A ball is dropped from a height, sorry, not height. A ball is dropped from a high-rise platform at t equal to 0 starting from rest. After 6 seconds, another ball is thrown downwards from the same platform with a speed v. The two balls meet at t equal to 18 seconds. So first ball is dropped. After 6 seconds, another ball is dropped from the same height. And two balls meet at t equal to 18 seconds. What is the value of v? Tell me. Tell me, what will you do? How will you solve this? Anyone? Indusha? Okay, so a ball is dropped from some platform, high-rise platform. Okay, and suppose it comes over here, then another ball is dropped at 6 seconds. And what's given? That after 18 seconds. So what's the difference between these two? 6 seconds. After 18 seconds, these two balls meet at some height. Okay, so this is at 18 seconds. Right, this is at 18 seconds. So this is simple. Which thing is equal for them, both of them? So first, that blue ball was dropped from here. It comes till here in 18 seconds. After 6 seconds, this red ball is dropped. So which thing is equal for them? The distance covered is equal, right? Okay, it's option A. Let's check. Distance covered is equal. Okay, yes, no, Selva Kumar?
Yes, sir.
Okay, so then what is distance covered? So for the first ball, it is just equal to, so I can just say that S1 is equal to S2, and for first one, it's just equal to half of gt square. Okay, half of g into t1 square, because t1 will be equal to 18 seconds. Okay, it takes 18 seconds to cover this distance. What about second one? it gets just 12 seconds because it is dropped, not dropped, it is thrown after 6 seconds. So it is just getting 12 seconds, 18 minus 6, 12 seconds, right? So S2 will be equal to UT, it is thrown, plus half of, okay, UT2 let's say, plus half of G into T2 square, okay, and it's thrown with velocity V, so U is V. So then what we can do is we can move this thing on the other side, okay. So it's half of G into T1 square minus T2 square is equal to V times T2, and therefore what is V? V is equal to G into T1 square minus T2 square. So again I will write this thing as, this is G, okay, this is not 9. So T1 plus T2, T1 minus T2 divided by, you have that 2, and this T2 also I am taking from other side, right? And then you can substitute the values, okay. What is T1 and T2? 18 and 6, right? So that's equal to G is 10, okay, G is 10 multiplied by 18 plus 6 multiplied by 18 minus 6 divided by 2 times of T2 is 12. No, T2 is 12, sorry. No, 18 plus 12 multiplied by 18 minus 12, right? T2 is 12. So 18 minus 12 is 6. 6 by 12 is what? 1 by 2, okay. So this thing is 30. 30 times 10 is 300. So you have 300 divided by 4. 300 by 4. That is 75. So V is 75 meters per second. Okay. Right, good. Okay, so Yamini is solving problems, others are not. Anyways, no problem. Let's discuss next one. Okay, a particle moves in a straight line with a constant acceleration. It changes its velocity from 10 meters per second to 20 meters per second while passing through a distance of 135 meter in t seconds. The value of t is. Tell me, what will you do? So initial velocity is 10 meters per second. Particle is moving with constant acceleration. Initial velocity is 10 meters per second. Final velocity is 20 meters per second and distance covered is 135. Okay. And they are asking you to find out the time. Anyone? See, that's simple, no? Okay, you have V is equal to U plus AT, right? So you know V, you know U. Do you know A? You don't know, right? So from this equation, V square minus U square is equal to 2AS. You can find out A, right? So find out A from that. V square is V minus U, V plus U, V minus U, V plus U divided by 2S. Okay, so put the values. So 20 plus 10 multiplied by 20 minus 10 divided by 2S. What is 2S? That is 2 times of 135. So this is 30, this is 300, 300 by 2 is 150, 150 by 135. So for now I am just keeping it 150 by 135. Okay, and from here we can find out the time. So what's the time? Time is equal to V minus U divided by A. V minus U upon A. V minus U is 20 minus 10 divided by acceleration. Acceleration is 150 divided by 135. So that 135 will go into the numerator, 135. Okay, so that's 10. Okay, this thing becomes 10. So that is 1350 divided by 150 or that is 135 divided by 15, so that's 9, right? 9 seconds. That's the answer. This is clear? Yes, no? Everyone?
Yes, sir.
Okay, very good. But then now what I will do is I will solve this in 20 seconds. See how. So now this is a straightforward method. Okay, not to say that the other method that I am saying is not that straightforward. So we are used to doing this thing, right? This is initial speed, this is final speed, then if we have displacement, right, then we tend to use this formula, v square minus u square is 2as. But see, I wrote that fourth equation, if you remember if you remember. So average speed is given by what? U plus v by 2. That's it. Average speed is u plus v by 2. So how much is that? 10 plus 20 by 2. So that is 30 by 2 means 15 meters per second. So this is the average speed. How can you write down the average speed? It's the distance covered divided by time taken. So if you want time, that is just distance covered divided by average speed. So distance covered is 135, average speed is 15, 135 by 15 is 9 seconds. This thing is clear? Yes, no? Okay, so you can solve it very quickly, right? You need to remember all those formula, and most important thing is now we should be aware, okay, these three things are given: initial speed, final speed, and the distance is also given. That means time is required. So from this we can very quickly find out the average speed. Then time is just what? Distance covered divided by average speed. That's it. Okay, all right. So this is just to demonstrate that we can use certain tricks. Okay, but finally it depends. It depends on our state of mind mostly, and these tricks will keep on coming if you solve more and more problems. So okay, so now it takes me to the point, how many questions did you solve yesterday? Everyone, did you do the homework, the DPPs? And by the way, there is test on Sunday, so everybody has to give the test. Okay, all right, test based upon this much syllabus. Yeah, tell me. Somebody raised the hand, no? The timing, it will be available from 12 p.m. okay, and I am just keeping it for your convenience. It will be available for entire week, but I mean, if you want to make it a habit, just give it on Sunday. That's it. Sunday 12 p.m. 13 p.m. is 1 p.m. etc. Choose your time and give it on Sunday if you want to make it a habit. Okay, all right, then let's see next one. The distance traveled by a particle starting from rest and moving with the acceleration 4/3 meters per second square in the third second is. Okay, so this is slightly different one. Distance traveled in third second. So suppose you throw an object, or it's in acceleration, so we can think like this: an object is thrown, okay, just acceleration is different. Okay, in first second it covers some distance, right, that is s1. In next second it will cover some distance, that is s2. In next second it will cover some distance, that is s3. Okay, so the total distance covered is suppose s3 in first 3 seconds. Okay, let's say s3 is the distance covered in 3 seconds. Distance covered in 3 seconds, right? And S1 is S2 is equal to distance covered in 2 seconds. Then what will be distance covered in third second? So distance covered in third second, distance covered in third second will be equal to what? Let's suppose S, it's equal to what? S3 minus S2, right? So it is just moving under constant acceleration and initial speed is 0. Okay, it's starting from rest. So this is just equal to half of g into t3 square, you can say, or time is just 3. Oh, not g, acceleration is 4 by 3. Half of a into t3, that is 3 seconds, that square, minus half of a into 2 square. Okay, and then it's just equal to, see, half a you can take common, half a multiplied by 3 square minus 2 square, so that is 9 minus 4, right? So that's equal to half of a is 4 by 3, a is 4 by 3 multiplied by 9 minus 4 is 5, so 20 by 6, how much is 20 by 6? Is 10 by 3, is 3.33, so 10 by 3 is there, so 10 by 3 is the answer. That's option A. Okay, this thing is clear, everyone? Okay, very good. So then now see, so a formula can be made like this. We can find out distance covered in last 1 second. Okay, object starting from rest, distance covered in last second. Okay, and you can just remember this formula. So see, so in 1 second, in n second, let's say Sn is the distance covered in n second, and Sn minus 1 is distance covered in n minus 1 second. So what would be the distance covered in last second? So distance covered in last second would be equal to Sn minus Sn minus 1. Okay, that is equal to this thing will be equal to half of a into n square minus half of a into n minus 1 square, right? Now again a by 2 you can take common, then it is n square minus n minus 1 square, so that is just equal to n plus n minus 1 multiplied by n minus 1, right? And that's equal to, you have 2n minus 1, and this n minus 1 is just 1. Okay, so it's a multiplied by 2n minus 1 divided by 2. Okay, let's call it S only. The distance covered in last second is a times of 2n minus 1 divided by 2. So this thing is clear. So for the last problem, just substitute a is equal to 4 by 3, n is equal to what? 3. Okay, because they are asking third second. They are asking about distance covered in third second, right? Okay, very good. So you can just remember this formula because they keep on asking these kind of questions. Okay, let's see next one. Two bodies, A of mass 1 kg and B of mass 3 kg are dropped from heights of 16 meters and 25 meters respectively the ratio of time taken by them to reach the ground is? Tell me. Two bodies, A of mass 1 kg and B of mass 3 kg. It's option A. Yeah, correct. It's option A. Very good, Indusha. Okay, so we have this formula, no? H is equal to half of gt square, right? H is equal to half of gt square. Yes, no? The body just dropped. So you will have h1 by h2, okay? Or you can say that h is directly proportional to t square, and therefore you can say that h1 by h2 will be equal to t1 by t2 square. Okay, so then t1 by t2 is just equal to square root of h1 by h2. So t1 by t2 is just equal to root of h1 is to h2, and just put the values, right? So t1 by t2 is just equal to square root of h1 is 16, so 16 by 25, that's 4 by 5. Okay, so that is very simple, right? Sophia? Okay, this is correct. Okay, good. Let's see next one. A ball is thrown vertically upward. It has speed of 10 meters per second when it has reached 1/2 of its maximum height. How high does the ball rise? Tell me. Okay, so here you remember one thing, that if you throw an object upwards with some velocity, let's say 20 meters per second, it will go to some height. Okay, it will stop there. Stop there means not for this much time. Okay, its speed becomes 0, it comes back, right? And it hits back with the same velocity. Okay, it hits back with the same velocity. Now where does this thing come from? It comes from the conservation of energy. Okay, it comes from the conservation of energy, right? So the kinetic energy here becomes potential energy at height h. Okay, and then means according to law of conservation of energy, energy cannot be destroyed. Okay, so the body has same energy all the time, just kinetic becomes potential, and when it comes back, that potential energy gets converted to kinetic energy, right? So now you can remember it in this way. Suppose at any height, a ball is thrown upwards. Okay, ball is thrown upwards from here. You're throwing it upwards. Ball, any object. Okay, it goes to the height h. So now it was here, suppose. Okay, it was here at some time, and this is any height. Okay, you don't know. Then at this height it had some velocity. Okay, at this height it had some velocity. So time it takes to go from here to here and time it takes to come back from here to here, it would be equal. Okay, time it takes, we can prove that time it takes to go from here to here, so from this height to the maximum height, and time it takes to come back from here to here, it would be equal. Also its velocity at this point would be equal in both cases, when it is moving upwards and when it comes back, the velocity at this point would be equal. Is this thing clear? Yes, no?
Yes, sir.
Okay, everyone?
Yes, sir.
Right? So then, now can you solve it? Very easily you can solve. Okay, it now it has speed equal to 10 meters per second. How high does the ball rise? Okay, so now they are saying that it has gone till the height of 1/2 and its speed is equal to 10 meters per second, right? Height is h by 2, speed is 10 meters per second. Okay, how high will it go? So if it is released from here, it will come to this point. So let's say this distance is h by 2 now. Let's call this distance h by 2. Okay, it goes from here to here with some velocity 10 meters per second. So you can think of it like this: if it is released from here, it will come to this height, it will come this much down. Okay, and at that point its velocity will be same. So then you can apply v square is equal to what? U square, which is 0. Okay, if it is released from here, and then it's just equal to 2 times g into the distance s. And what is s? S is equal to h by 2. It's 2 times of g multiplied by h by 2. Okay, so therefore g is 10. You can put that. So yeah, this will be gh, and what will be h then? H will be just equal to v square divided by g. So that's the answer. That is 10 square divided by 10 means 10 meters. This is the answer. This thing is clear? Everyone?
Yes, sir.
Right? Okay, so just remember these two things. If you throw some object with some velocity, okay, when it comes back to the same point, its velocity would be equal. Second thing is the time that it takes to go from there, okay, to the highest point is same as that of time it takes to come from that highest point to this point. Okay, two things, right? And actually we'll see that in projectile motion, the time it takes for upward journey is equal to time it takes to go downwards, okay, for the downwards journey. All right, let's see the next one. If the ball is thrown vertically upwards with speed u, the distance covered during the last t seconds of its ascent is? Ascent is. It is called as ascent, no? Or it is ascent? I think there is a spelling mistake. Or is that fine? Anybody who is good with spellings? It is just called as, I think it is just called as ascend. Okay, ascend is correct. But is ascent correct? It is ascend, no? Okay, it's ascend only. It's moving upwards. All right. So last t seconds, how much distance will it cover? Tell me. It's option B. Okay, as I just explained, right? This thing is clear. Okay, yeah, very good. All right, let's see next one. A particle is thrown vertically upward. Its velocity at half of the height is 10 meters per second. Then the maximum height attained by it. Tell me. Particle is thrown vertically upward. Its velocity at half of the height is 10 meters per second. Then maximum height attained by it will be? It's the same question, no? Particle is thrown vertically upward, its velocity at half of the height is 10 meters per second, then the maximum height attained by it. Yeah, same question. Is the year same? No, that's 2005, this is 2001. Okay, so we just found the answer for this. It is 10 meters, right? Okay, it's the same question. All right, let's see next one. A car moving with speed of 40 kilometers per hour can be stopped by applying brakes after at least 2 meters. Okay, the same car is moving with the speed of 80 kilometers per hour. What will be the minimum stopping distance? So here you will assume that when you apply brake, you are applying the same force. That means the acceleration would be equal in both cases, right? Actually, it is negative acceleration because you are applying brakes. Tell me. What will you do? Okay, here see, when you apply brakes, it's option C. Okay, let's check. 8 meters. It might be true. Let's check. Okay, so when you apply brakes, V square is equal to, you know, U square minus 2as. Why minus? Because acceleration is negative. Okay, a is negative, right? Or you can say that V square is U square plus 2as, but this value of a would be negative. Either you can take negative sign there, or you can just write V square is equal to U square minus 2as, right? So then V square, V would be equal to 0, and that means U square is just equal to 2as. So in the first case, its U1 square would be equal to what? 2as1, and in second case, its U2 square should be equal to 2as2, right? And you can just cancel out these things. So you have U1 by U2 square. U1 by U2 square is equal to S1 by S2. Okay, and that is, what is U1? It's 40. So 40 by 80 square is equal to, S1 is 2, S2 is, we don't know, we need to find it out. So this is 4 by 8 means 1 by 2 square. 1 by 2 square is 1 by 4. Yeah, so 1 by 4 is equal to 2 by S2. So S2 would be equal to 8. Good. It's 8 meters. Okay, this is also simple, right? Everyone? Okay, that's very simple. So if there is a problem based on stopping distance, just directly you can write that U1 by U2 square will be equal to S1 by S2. Okay, U square is directly proportional to S. This is the formula. Right, U square is directly proportional to S. All right, then there are similar problems. So like, if a car at rest accelerates uniformly to the speed of 144 kilometers per hour in 20 seconds, it covers a distance of, this is very simple. Here you need to apply what? Starting speed is 0, so V square is just equal to 2as, and you want S, it will be equal to V square by 2a. Just convert that V, which is 144 in kilometers per hour, to meter per second. So multiply it by 5 by 18, right? And what is this thing? 144. Is it there in the table of 18? Yes, it's 18 8s are 144, right? 8 5s are 40. Okay, so then this is 40 meters per second, and then you can substitute values. So 40 square divided by 2 times a. Okay, oh, a car accelerates uniformly to speed of this much in 20 seconds. Okay, so V is equal to U plus 80, you know. So V is equal to U plus 80. U is 0, so it is just equal to 80, and from that you find out A. So A is equal to 40 by time is 20, so A is equal to 2. You substitute that 2, right? This is 40 square, that's 40 into 40 divided by 4, so that's 400, right? 40 by 4 is 10, 10 times 40, 400 meters. So this is the answer. Okay, this thing is clear? Yes, no? Everyone?
Yes,
Yes,
sir.
sir.
Okay, good. So now maybe, just maybe, I don't know, if you are something like me, you don't remember the tables, because I don't remember the tables. Okay, most of them. Okay, after 10, 11, it's difficult for me. Okay, so then what you can do, you want to find out 18 8s are, what will you do? So I can just write this thing as, okay, I can do this in two ways. So it is 20 minus 2, 18 is 20 minus 2 times 8. Okay, 28s are what? This thing is doable, right? 28s are 160 minus 2 8s are 16. 160 minus 16 is 144. This thing is clear? Yes, no? Okay, another way to do, 18 8s are 18 times 10 minus 2, right? So that's 180 minus 18 2s are 36, so that is 144. So if you don't remember the tables, you can do this thing. Okay, because multiplying 18 with 8 will take some time. Doing these things don't take that much time. And actually I didn't remember what is 18 8s. Okay, what I did in mind when I said yes, it's that. Okay, 18 8s are 144, so I did this second thing. Okay, you won't believe, but I did that thing. So this is a neat trick, okay, which will be helpful in NEET. Anyways, this is clear, everyone, how to do calculations if you don't remember the tables? Okay, good. Let's see the next question. A body dropped from a height h with initial velocity 0 strikes the ground with velocity 3 meters per second. Another body of same mass dropped from the same height h with an initial velocity of 4 meters per second. The final velocity of second mass when it strikes the ground is, tell me. So first body is dropped from height h with initial velocity 0, strikes the ground with 3 meters per second. Okay, another body of same mass dropped from the same height, that mass does not matter, with initial velocity 4 meters per second. The final velocity of second mass, tell me, when it reaches the ground is. Sorry. Okay, that's simple. See, first body's final velocity is what? 3 meters per second. What does that mean? So v is equal to, you know, it's root 2 gh, or you have v square is equal to 2 gh. So from this you can just find out the height. Okay, you can just find out the height. So let's call it v1 because it is for first mass. So height would be equal to v1 square by 2g, right? And then what is v1? It's 3 meters per second, so it's 3 square by 2g. 2g means 2 times 10. Okay, so 20, 9 by 20. So you got the height, and then second mass is thrown. It's thrown with this much velocity, right? Initial velocity is 4 meters per second. What would be the final velocity? That's the question. So you have v square is equal to u square plus 2gh, and there we can put the values. So it is 4 square plus 2 times of 10 into 9 by 20. Okay, so this 20 gets cancelled out. 4 square is 16, 16 plus 9 is 25, so v square is 25, so v just equal to 5 meters per second. Okay, so this is the answer, right? Very simple. Okay. I'm sorry. Let's see another question. the water drop falls at a regular intervals from a tap 5 meters above the ground. The third drop is leaving the tap at the instant the first drop touches the ground. Okay, drop number 1 comes down, drop number 2 comes down, then drop number 3 just comes out of the tap. At that time the drop number 1 touches the ground. This is given. Okay, how far above the ground is the second drop at that instant? How far above the ground is the second tap? Second drop at that instant? This is the question. Tell me. So drop number 1. This is drop number 3. Okay, it's option D. Let's check. This is option D. Is it option D? Alright, so this is drop number 3. This is third one. This is second, and this is first. First one reaches the ground. Okay, this is first. Right? And the drops are falling after regular intervals. Okay, so interval is fixed. Let's say 1 second. So at 1 second first drop is coming. Sorry, at the 0 first drop is coming. 1 second second drop is coming. Okay, 2 seconds third drop is coming. Right, like that. So the distance covered by this one and distance covered by this one, what would be the ratio of that? Tell me. So this much distance is covered. Suppose second drop gets 1 t, right? So this is t, distance covered by the first drop. So first drop would get 2t, right? Okay, so this distance is suppose s1, therefore distance covered by second drop, this is s1. This distance would be equal to what? Let's call it s. So this distance and this distance, what will be the ratio of that? So we know s1 is to s2 is what? 1 is to 3. So s2 is equal to 3 times of s1. That means total distance s, or you can say the height, this is the total height, h is equal to s1 plus s2, right? s1 plus s2. So that is s1 is s1, s2 is 3s1, right? s1 plus 3s1, that is 4s1, and therefore what will be, this total distance is 4s1. That means what will be s1 is, it's h by 4. Okay, so that's 5 by 4. 5 by 4 means 1.25 meters. So this distance is 1.25 meters. So how high this second drop is above the ground? Tell me. Is it 1.25? No, 1.25 is this distance. Yeah, it's 3.75. Very good, Yamini. It's 3.75, right? So how high is the second drop? So S2 is just equal to h minus what? S1. That's 5 minus 1.25. So that is 3.75 meters. So this is the answer. Okay, this is clear. So this is good question. Again based on Galileo's law. Okay, so Galileo is big saver, right? All right. So then I guess other questions would be similar. Yeah, other questions are similar, so you can just try them. Let's see this one. The velocity of a train increases uniformly from 20 kilometers per hour to 60 kilometers per hour in 4 hours. The distance traveled by the train during this period is very simple, right? And we don't even need to change the units from kilometers per hour to meters per second, because the time is also given in hours, right? So Tell me, how will you solve this? It changes from 20 to 60 in 4 hours. So just find out the average velocity. Average is what? 20 plus 60 divided by 2. How much is that? 80 by 2. So 40 kilometers per hour is the average. And the distance covered is just equal to V average multiplied by time. That is equal to 40 multiplied by time is 4 hours. So it's 160 kilometers. This is the answer. Okay, either you can do this way, which is the quickest one, right? Or what you can do is you can find out the acceleration. Acceleration is equal to what? V minus u divided by t. So 60 minus 20 divided by t is 4. So 60 minus 20 is 40. 40 by 4 is 10. Okay, but that is in kilometer per hour square, not meter per second square, right? That is the acceleration. Okay, and then the distance s is equal to, you can say ut plus half at square. Either this formula you can use, or you can use this formula. V square is just u square plus 2as. Okay, put the values. So u square is 20 square plus 2 times of 10 multiplied by, no, we want distance, no? So s only, sorry, s is ut plus half at square. Ut plus half at square. So that is u is what? 20 times t is 4 plus half of a is what? 10 times 4 square. So either way you will get the same answer, but this thing will take some time. Okay, and that's why presence of mind is important. So this is 80 plus this is 4 square is 16. 16 times 10 is 160. 160 by 2 is 80. So 80 plus 80 is 160 kilometers. Okay, so answer will come out to be equal, but this will be much faster, right? This thing is clear, everyone? So let's begin with the next topic, that is the position versus time graph. Okay, so again let's come to the same example. Suppose this is me and I am walking along this straight road and there is this tea shop. Okay, so suppose and then here, okay, there is some newspaper, okay, newspaper shop. So I go like this, I walk along this straight road, then I take tea over here, or I keep on walking and I go to that newspaper shop, then I come back and I stop here at the tea shop. I read the newspaper with a cup of tea. Okay, so this is my motion. Now suppose I want to plot it. Okay, so I will plot my position on this vertical axis and the time on the horizontal axis. So this graph may look like this, something like this. Okay, so initially my speed would be very zero. If I am starting the jogging in the morning, my speed would be very zero initially. Then I will increase my speed. Then once I see that newspaper shop, I will stop over there. Okay, so here my speed will become 0, and again now this is happening in very fast, right? But in reality it won't happen that fast. But suppose the time I take the newspaper, okay, just like the players in the marathon, they pass on the baton. Okay, just like I take the newspaper, I come back over here and I stop over here. So the graph looks something like this, right? So this is position versus time graph. Now what kind of information do we get from this graph? So first of all, we can find out the average velocity between the start point and end point. What would be the average velocity? So at the start point, my position was 0, time was 0, and this is the end point, which is point C. Then my position is suppose something, okay, suppose that is x2 and time is t2. Okay, at the start point you can say position is x1, time is t1, and at the end point position is x2, time is t2. Then we can find out velocity. Velocity would be just equal to x2 minus x1 divided by t2 minus t1. That is my velocity. The change in position divided by change in time. That is the velocity, right? And what would be the speed? How will you find out the speed? So to find out velocity, what will you do? It is the difference between the positions of these 2 points. This is final position minus the initial position, okay, divided by the time. But if you want to find out the speed, that is total length of the path covered. Yeah, that is distance divided by time. So total length of the path covered. So you will go from A to B. Okay, you will calculate that distance, and then you go from B to C. You calculate that distance, right? So the average speed would be equal to just this total distance divided by the time. Okay, right? And which one would be greater? Velocity would be greater or speed would be greater? What do you think? Speed would be greater, right? Because distance covered is more than displacement. Speed would be greater. Okay. Now suppose this is any x versus t graph. So this is for the uniform motion. Okay, this is for the uniform motion. So slope of this graph will give us the velocity. Okay, so how do we find out the slope of a line? We learned it in basic mathematics, but anyways we'll just recall it. So suppose this is a straight line and I want to find out its slope. Okay, so this line is what? This is position versus time graph of any motion. Okay, so I want to find out the velocity. So what I will do is I will just take any 2 points on the graph, right? I can take this point which is x1 t1, okay, or this point which is x2 at t2, right? We write actually the horizontal coordinate first. So it is t1 x1, right? This one is t2 x2 and this point is t3 x3. So the slope is given by x2 minus x1 divided by t2 minus t1, or you can say it is given by x3 minus x2 divided by t3 minus t2, right? So you can choose these 2 points, or you can choose these 2 points, or you can choose this point and this point, and you can find out the change on the vertical axis, which is called as rise, divided by change on the horizontal axis, which is called as run. Okay, so velocity is just slope of the position versus time graph, that is the average velocity, and we know that the slope is equal to, suppose this line makes some angle with the vertical axis, sorry, horizontal axis, that angle is theta. Okay, this line makes an angle theta with the horizontal axis. Then what is the slope? Slope, if you see, it is the tan of this angle theta, right? It is just tan of this angle theta, right? So see here, x2 minus x1 is this much difference. So if you consider this triangle, then it is this opposite side divided by adjacent side, right? So x2 minus x1 divided by t2 minus t1 is just tan of theta. Okay, so these are 2 different ways of finding out the slope, right? Now let's come to this point. So suppose this is x versus t graph of 2 students, or you can say 2 cars, anything, any 2. So this is A. Okay, this is position versus time graph of A. This is position versus time graph of B. Which one is faster out of these 2? B is faster or A is faster? Who is faster? B is faster, right? Because slope of B would be greater than slope of A. Yeah, angle is more, so slope of B is greater than slope of A, right? This is very simple. B is faster compared to that of A. Okay, so then now okay, so this is simple. After that, now we are studying graphs for motion. So first type is x versus t graphs, okay, that we started with. So now let's consider various cases for this x versus t graphs. Okay, so suppose object is at rest, how will its position versus time graph look like? It looks like this. It's a straight line. Okay, it's a horizontal line, right? It's parallel to time axis. Why? Because suppose the object starts from this position, so at t equal to 0 it's here, at t equal to, let's say, 1 second or something, it's here at the same position, at t equal to 2 seconds it's here at the same position. If you join all these points, what will you get? You get a straight line, okay, parallel to horizontal axis, right? Then if object moving with uniform velocity, if object is moving with uniform velocity, then what happens? The graph will look like this. Okay, we can plot it. The graph will look something like this. And then next is uniformly accelerated motion. So for uniformly accelerated motion, the graph will look like this. And if the motion is retarded, retarded means decelerating motion, okay, if velocity decreases, then graph will look like this. Okay, for uniformly accelerated motion, the graph will look like this. For uniformly retarded motion, the graph will look like this, right? So now you can think of it from here actually. So see, now suppose velocity of b is greater than a, that's clear, right? And suppose a wants to increase its velocity. Okay, a wants to increase its velocity, so its position versus time graph, it will change like this, right? Suppose a wants to increase its velocity, so what will happen? Its position versus time graph, it will start like this, but it wants to increase the velocity, so it's increasing, so it will go towards b, because here the velocity is increasing, you can say, okay, because velocity of b is greater than a. So if position of a changes like this, that means a is running faster. So this would be the graph of accelerated motion. Okay, on the contrary, suppose you can think of b wants to decrease its velocity. Okay, so how will its position versus time graph look like? So b decreases its velocity, and its velocity at some time becomes equal to that of a. So position versus time graph of b will look like this. Okay, it will start along this line of b, and then it will tilt towards what? A. So this is the graph of retarded motion, okay, decelerating motion. This thing is clear? Yes, no? Everyone? Okay, good. So this is the position versus time graph. So this is object at rest, uniform motion, uniformly accelerated or uniformly retarded motion, right? Then if nothing is uniform, then it will look something like this. So this is not at all uniform motion, right? Okay, all right. Then next, let us see velocity versus time graph. So in case of velocity versus time graph, if your object is at rest, how will its velocity versus time graph look like? So it will look like this. Why? Because at t equal to 0, your object is at rest, that means velocity is 0. At t equal to 1 second, the velocity is 0. At t equal to 2 seconds, the velocity is 0. So if you join all those points, then you will get what? You will just get this horizontal line, and it is just time axis. It's not parallel to time axis, it is time axis, right? This is clear? Okay, good. Then for uniform motion, if velocity is constant, velocity is not changing, so velocity versus time graph will look like this, right? Velocity versus time graph will look like this, right? Because at t equal to 0, the velocity is suppose v0, 2 meters per second or something like that. At t equal to 1 second, still the velocity is v0. Okay, so same velocity. T equal to 2 seconds, same velocity. So therefore the graph will look like this. Then comes the point, if it is uniformly accelerated motion. If it is uniformly accelerated motion, that means the velocity is increasing uniformly. So it will look like this. It will look like this, right? The graph will be a straight line. Okay, it will look like this, and slope of that line will give you what? Acceleration. Okay, but now suppose acceleration is increasing, then how will the graph look like? Then the velocity versus time graph will look like this. Okay, increasing acceleration. If acceleration is constant, velocity versus time graph will be a straight line. If acceleration is increasing, the graph will look like this. If acceleration is decreasing, then the graph will look like this. Okay, this is clear, everyone? Good. So this is uniformly accelerated. This is for the acceleration is increasing. This one is for the acceleration is decreasing, and this one is for the acceleration, it's with negative acceleration. So here the velocity is increasing uniformly, here the velocity is decreasing uniformly, right? Velocity is decreasing uniformly. Okay, this one is for uniformly retarded motion. Okay, all right. So now we have seen that if you find the slope of position versus time graph, it gives you velocity. Okay, so now from velocity versus time graph we get two pieces of information. One is you get displacement and one is you get the acceleration. Okay, so see how. So just for an example, let's consider simple graph that velocity is constant. Okay, velocity is what? Constant, right? So here, see, we know that velocity is what? Change in position divided by change in time. This is displacement upon time. So x2 minus x1 is displacement, t2 minus t1 is time. Take t2 minus t1 on this side. So what do you get? You get x2 minus x1 is equal to v into t2 minus t1, right? x2 minus x1 is equal to v into t2 minus t1. And if you see that on this graph, what is v? V is the velocity. What is t2 minus t1? T2 minus t1 is this side. So if you just see it over here, v is this side, okay, of this rectangle. Yeah, it's the area, and t2 minus t1 is this side. So v multiplied by t2 minus t1 will give you area under this curve, and from where to where, that is important. It will give the area from t1 to t2. Okay, so this area is what? It's equal to x2 minus x1. That means it is equal to the displacement of object from time t1 to time t2. Okay, so area under the vt curve from t1 to t2 is equal to the displacement of the object from time t1 to time t2, right? Okay, this thing is clear. All right, good. Then next thing, so suppose this is the velocity versus time graph. We can take any velocity versus time graph. Okay, we can take this one as well, but now I wanted to find out the slope, and slope of this one is 0, velocity is constant, right? So we know acceleration. What is acceleration? Acceleration is change in velocity divided by time. So it's final velocity at some time t2, you can say, okay, or velocity at time t2 minus velocity at time t1 divided by t2 minus t1. Okay, it is the acceleration, right? Change in velocity upon time. So here if you see that on the graph, acceleration will be the slope of velocity versus time graph, because if this is time t1, this is time t2, this one is velocity at time t1, this one is velocity at time t2, right? This is the velocity at time t2, v2 is the velocity at time t2. Then v2 minus v1 is this much length, okay, or this much length, that is change on the vertical axis, divided by t2 minus t1 is change on horizontal axis, and change on vertical axis divided by change on horizontal axis gives us what? Slope. Okay, So the acceleration is given by the slope of velocity versus time graph. Right? This thing is clear, everyone? Okay, good. And then next one is AT graph. AT means acceleration versus time graph. So if for uniform motion it will look like this because acceleration is 0. For uniformly accelerated motion, so now here sometimes students get confused that this graph is acceleration versus time and you want it for uniformly accelerated motion. Okay, so for uniform motion, velocity versus time graph is flat. For uniformly accelerated motion, the acceleration versus time graph would be flat like this. Okay, so we need to remember which motion we are talking about, right, in order to draw the graphs or understand the graphs or identify the graphs, right? Okay, so this one is for uniformly accelerated motion. This is for increasing acceleration. Now this one can be like this also, it can be like this also, because if I draw like this, still the acceleration is increasing. Okay, so this is also for increasing acceleration, but this is uniformly increasing acceleration, right? And this is decreasing acceleration, so this is uniformly decreasing acceleration. These graphs are clear? Yes, no? Okay, good. And then what do we get from the acceleration versus time graph? So if we find out the area under acceleration versus time graph, we get the change in velocity. Which graphs? These graphs?
Yes, sir.
Increasing acceleration.
Uniform motion and uniformly accelerated motion.
Uniform motion and uniformly accelerated motion. Okay, so uniform motion is like, see, example can be anything. Suppose you take your bike, okay, you're riding on your bike and you constantly see 40 kilometers per hour. That is uniform motion.
Yes, sir.
And if you just accelerate the bike, what will happen? It will go from 40 to 50, something like that. Okay, it happens in no time for the bike, but suppose it takes some 10 seconds. So that is the uniformly accelerated motion.
Okay, sir.
Right? If you want to see natural example, the natural example is motion of an object under the gravity. Okay, if you release something, if you drop some object from some height, it falls down under the gravitational acceleration. So that motion is uniformly accelerated motion.
Okay, sir.
Right?
Okay, sir.
Okay, but that acceleration is negative. So if you want to plot the graph of gravitational acceleration versus time, it will not look like this because the acceleration is negative. It will be below the time axis. Okay, for gravity, the graph will look like this.
Okay, sir.
Why? Because the acceleration is negative.
Negative.
Okay, so A is equal to minus G. Minus G means minus 9.8 meters per second squared. Right? Acceleration is negative, meaning it's in negative direction. Okay, right? It's along negative y-axis. That's why the graph will look like this. Sorry. So this is simple, right? Okay, so now we need to remember these things. The slope of position versus time graph gives velocity. Okay, slope of position versus time graph gives velocity. Then from velocity versus time graph you get two things. One thing is, if you find the slope, you get acceleration. Second thing is, if you find the area under the curve, you get displacement, right? And from acceleration versus time graph, if you find area under the curve, you get change in velocity. Okay, from acceleration versus time graph, if we find the area under the curve, we get change in velocity. So this is clear, right? Then now let's see simple problems. The acceleration of a moving body is found from the, tell me, area under the VT graph, velocity versus time graph, area under displacement versus time graph, or slope of distance versus time graph, or the slope of velocity versus time graph, area under the acceleration versus time graph. Which one is correct? Yeah, very good. It's option D. Okay. Let's see next one. In the figure below represents a parabola. Identify the physical quantities representing y and x for a constant acceleration. If acceleration is constant, then what will be y and which thing will be x? Tell me. X is time, y is velocity, or x is velocity, y is time. X is time, y is, okay, Yamini is saying it's option C. X is time and y is displacement. Yeah, very good. It's option C. Okay, so we just saw the position versus time graph, or you can say displacement versus time graph of uniformly accelerated motion will look like this. So this is also very simple, right? It's from KCET, Karnataka CET. Alright, let's see next one. The speed time graph of a particle moving along a solid curve is shown below. Okay, speed time graph is shown below. The distance traveled by the particle from t equal to 0 to t equal to 3 seconds is, tell me, distance traveled from t equal to 0 from here to t equal to 3 seconds is, so this is speed versus time graph. What will we do? So distance is equal to just area under the speed time curve, right? It's just area under the speed time curve. Okay, so that is equal to, what is the area under this curve? So it is half of base into height. This is just a triangle, right? This is just a triangle. So it's half of base into height. So what is base? Base is 3. What is height? It's 1.5. So it's half of 3 times h is 1.5. Okay, so that is 4.5 divided by 2 means, that is correct, no? 4.5 divided by 2, that should be the answer. We want t equal to 0 to t equal to 3 seconds, right? 2.25 should be the answer. Okay, so out of these, none of the options is correct, right? So let's say it is E is equal to 2.25. Okay, correct, no? I don't think I can make mistake in this one. Yeah. Okay, so let's see next one. The displacement time graph of two moving particles make angles 30 degree and 45 degree with the x-axis. The ratio of their velocities is. So we know what is the velocity. Velocity is given by, if you have angle made with the x-axis, if you have position versus time graph, and the graph makes some angle with the time axis. Okay, x-axis means time axis here. Then what is velocity? It is tan of theta, right? So what is, you want ratio of their velocities, tan 30 to tan of 45, right? tan 30 to tan 45. Is it option D? Okay, so tan 30 to tan of 45. So that's equal to, what's tan 30? Tell me.
1 by 2.
1 by root 3. Right. 1 by root 3. And what is tan of 45? Tan 45 is 1. Okay, so that is just equal to 1 by root 3. It's very, very simple. Okay, so it's option D. Alright, so if we remember this, then it's very simple. Alright, let's see next one. These are very, very simple questions. Okay, we are starting with simple questions. Alright, which of the following graphs cannot possibly represent one-dimensional motion of a particle? Which of the following graphs cannot possibly represent one-dimensional motion of a particle? Anyone? Is it option B? B says 2 and 3. 2 and 3 don't represent the one-dimensional motion. Why is it so? Yes, Yamini? Yeah, because at one time they should have only one velocity and only one position, right? So for an example, if we think of this graph, okay, this is position versus time graph, and then if you just take some time, time is this one, suppose, okay, and you draw a straight line on the graph, then what will happen? You get these two positions, okay, this position as well as this position, right? So at this time the graph is saying that object was here also and object was here also. So it is not possible, right? For real objects it's not possible. It's not the God. Okay, I don't know God is, okay, whether God is there, if he or she, if it is present everywhere, right? We say that, no? So but objects in the real life, they can't be present at two different positions at the same time. Okay, yes, no? So this graph cannot represent the motion, okay, motion along a straight line. Anyways, let's come over here. So this is velocity versus time graph, and same goes with this one also. If we take some time, for an example, let's say this time, okay, so at this time the velocity of object is this one as well as this one. So you can say object is moving towards right as well as towards left. So this is not possible, okay, for real objects. So this is also incorrect. So that's why 2 and 3 is incorrect, and that's why the answer is option B. Okay, good, very good. All right, let's see the next one. Figures 1 and 2 show the displacement time graphs of two particles moving along the x-axis. We can say that this is the first one, this is second one. Okay, tell me. We have discussed both cases. Both particles are having uniformly accelerated motion. Okay, very good. Everybody is saying it's option C. So particle 1 is having uniformly accelerated motion and particle 2 is having uniformly retarded motion. Very, very good. So it's option C, right? Let's see next one. Area under the velocity time curve over a given interval of time represents. Tell me. Area under VT curve. It's option A. Good. What? Area under the VT curve. Area under VT curve. Yeah, it's D. It's not A. Okay, I was also, clicking A. and I saw acceleration there. All right, so it is option D, displacement. Good. So see, these questions, these are given for just for one sake of one thing, they can be asked. Okay, and one more thing, if you just revise the questions, if you just go through the questions, okay, then if you forget some concepts, okay, the concepts will become clear also, right, at the last moment also. Area under the VT curve, if you forget about it and if this thing is in front of you, okay, it gives displacement, right? All right, let's see next one. A body starts from rest and moves with uniform acceleration. Which of the following graphs represent its motion? Starts from rest and moves with uniform acceleration. So starts from rest means initial velocity must be 0. So it's 0 here, it's 0 here. Okay, but then this graph goes like this. So this is retarded motion. Actually no, initially velocity is increasing, no, yeah, initially velocity is increasing, then it becomes constant. It's that kind of motion. Okay, but here velocity is uniformly increasing. So this one is the answer. This is for the uniformly accelerated motion. Okay, very simple. All right, a body moves with uniform acceleration, then which one of the following graph is correct? Same question. So it is again this thing, uniform acceleration, right? Okay, let's see next one. The area of acceleration displacement curve of a body gives. So now can you think about this one? Area of acceleration displacement curve. On one axis, what is plotted? Acceleration is plotted, and on another axis, displacement is plotted. Okay, and let's say for simplicity, acceleration is constant. Okay, so then this is some x1, this is x2, and this is acceleration. If you take area under that, this curve, so area will be equal to what? It is acceleration. Okay, this is acceleration multiplied by x2 minus x1. Okay, acceleration multiplied by x2 minus x1. So tell me, or you can say this is the displacement. This is a times s. It is option C, change in kinetic energy per unit mass. Very good. Okay, you have this thing a times s, then you remember v square minus u square is equal to what? 2 times a into s. Okay, but then if you take that 2 on this side, it becomes half v square minus half u square is equal to a into s. And if you remember the formula for kinetic energy is given by what? Half of mv square. Okay, so if you take kinetic energy per unit mass, what do you get? You get half v square. So this is final kinetic energy per unit mass. Okay, kinetic energy divided by mass per unit mass, and this is initial kinetic energy per unit mass. So this thing is change in kinetic energy per unit mass, right? This is change in kinetic energy per unit mass, and it's equal to a times s, means it is area under this curve. Okay, so it is option C. This one is clear, everyone? All right, good. Okay, then let's see this one. Consider the given velocity time graph. It represents the motion of a projectile projected vertically upward from a point, an electron in hydrogen atom which revolves like this, okay, in circular motion, a car with constant acceleration along a straight road, a bullet fired horizontally from the top of a tower and an object in positive direction with decreasing speed. Which one? What's happening to the velocity? This is velocity time graph. So the velocity is decreasing. Here at this time it becomes 0. Then it's increasing in negative values. This is option D. So D is a bullet fired horizontally from top of a tower. No. Somebody else said something else. Option A, a projectile projected vertically upward from a point. Is it correct? When you throw a projectile upwards, okay, initially the velocity is maximum, then velocity goes on decreasing and direction is upwards, so you can take it as positive. So if we take this direction as positive, then velocity, what happens to the velocity? Initially it is maximum, then it goes on decreasing and it stops at some point. So velocity at that point becomes 0, right? Velocity there becomes 0 and again it comes back. So again the velocity increases, but it increases in negative values. Okay, the velocity increases in negative values. So this is correct, right? This one is correct. So it's a projectile projected vertically upward from a point. Okay, so its velocity versus time graph will look like this. Good. Let's see next one. A boy begins to walk eastward along a street in front of his house, and the graph of his displacement from the home is shown in the following figure. His average speed for the whole time interval is equal to. Tell me. You want to find out average speed. What will you do? This is displacement versus time graph. Tell me what will be the average speed? Okay, what will be the average velocity from here to here? Average speed is, you are saying average speed 8/3 meter per minute. So what did you do? Tell me. Vishalini? Distance into time. But distance into time, will it give you speed? Distance divided by time. Okay. Yeah. So what is the total distance? It's 40. Okay, 40 and then it comes back here. So 40 plus 40 is 80. 80 plus, how much is this? Is it 10? Oh, the graph is not good. The graph is starting from here. Okay. I guess it should start from 0. But this is 0, this is the 20. What would be this thing? 5 or something? I think this is a misprint. Okay, for the sake of understanding it, I will just shift the 0. Okay, the final answer may not match with what's the answer over there, because I don't know. Okay, so I will just mark 0 over here. Okay, so this is a new problem, you can say, because marking there is, it's not clear. So if this is 0 and that's 40, then it will be 40. Okay, distance covered is 40. When it comes back again, the distance covered is 40, and then I guess this should be 10. So, or yeah, this should be 10. So 10 and 10, so it's 40 plus 40 plus 10 plus 10. How much is that? Is, it's 100, right? 100 divided by time taken is what? 20. So that is equal to 5. Okay, but 5 is not there, so I guess this should be then 20 only. Okay, so I'm just trying to guess. So let's say that this is 20. Alright, so if this is 20, then it will be 6. This thing is clear? Yes, no? I have just changed the question, nothing else. Okay, because the marking was not clear, I have changed the question in such a way that answer will match with one of these answers. Anyways, let's see. So we want to find out average speed. So object goes from here to here, right? This is displacement. So average object displaces from 0 to 40, then from 40 to 0. Okay, he goes over there, stops there, comes back. Okay, so this is 40, again he comes back, so this is 40, 40 plus 40 is 80, right? Then he goes in negative direction. Okay, if you think about right and left, object goes in this direction, then comes back, then goes towards left, okay, and comes back, right? So this is 40 plus 40, 80, 80 plus this is 20 plus 20, so that means 40. Okay, so 80 plus 40, total distance covered is equal to what? Total distance covered is 120, and total time taken is what? From 0 to 20 minutes. Okay, so 120 divided by 20, it will be 6 meters per minute. Okay, so that's the answer. This is clear, everyone? Yes, no? Okay, Diveshwani, is it clear? All right, good. So this question is very simple, but the diagram was not clear. Anyways. All right, so let's move on to the next thing, that is instantaneous velocity. So now we know how to find out the average velocity, right? What is the instantaneous velocity? So once again, we had discussed this thing when we discussed mathematical methods, right? So suppose this is the position versus time graph, and it looks like this one. Okay, so this is the position versus time graph, and I want to find out the velocity of this object from time t1 to time t2. What will I do? So what I will do is, I will just take the change in position, okay, which is this one. Okay, this much is the change in position divided by change in time, so that's t2 minus t1, which is this much. So average velocity is x2 minus x1 divided by t2 minus t1, right? And then that average velocity is given by slope of this line. Okay, it is given by slope of this line, and this line is known as what? Secant line. Okay, this line is known as secant line. So if you take first point on the graph, if you take another point on the graph, draw a straight line passing through those 2 points, slope of that line will be equal to what? x2 minus x1 divided by t2 minus t1, and that slope will give you the average velocity from t1 to t2 in that time interval. Okay, then now if you decrease the time interval, so instead of this t2, suppose I take this t2 dash and I want to find out the velocity from t1 to t2 dash, then what happens? Is you get the velocity which will be slope of this line, which will be given by slope of this line. So this line is again a secant line. Okay, it intersects the graph at 2 points, but you can notice that this line is approaching closer to the graph, it's coming closer to the graph. Okay, so then if you decrease the time interval even more, if you take this time interval, let's say from t1 to t2 double dash, then what happens? The secant line again approaches closer and closer to the curve. So if you keep on doing this, what will happen? At a very small time interval, when time interval becomes very small, this line becomes tangential to the curve. It will approach very close to curve, and it will not intersect, because see, distance between these 2 points is also decreasing. Okay, so it will intersect the curve at one and only one point, and that line is known as what? Tangent. Okay, so that's what it is shown here. So if you decrease the time interval, so see, this time interval is very small compared to that one. So then what happens? The line passes, still this is appreciable time interval, right? So again the line will pass through 2 different points, right? So this will be still a secant line, but if you decrease the time interval even more, what will happen? So this line also, it's almost tangential to this curve. Okay, so if you make the time interval equal to 0, then what happens? The slope of a line which gives what? A line whose slope gives you the velocity, it becomes tangential to the curve, and that velocity is known as instantaneous velocity. So what is instantaneous velocity? It is velocity of an object in very small time interval. Okay, what instantaneous means? Right now. Okay, if you want velocity, right, you say I want the velocity, you get the velocity. Okay, that is instantaneous velocity. And how do you get that? From the xt curve. From xt curve, it is the slope of a tangent line, right? If you want velocity at time t1, you just draw a straight line like this. Okay, it will meet the graph over here. So this is point corresponding to what? Time t1. Just draw a tangent there. Then slope of the graph and slope of the tangent at that point will be equal. That means the velocity will be slope of the tangent to the graph. This thing is clear? Yes, no? Everyone? Okay, good, very good. So this slope gives us instantaneous velocity, and then now if time interval is very small, we know that we write it like this: limit delta t tends to 0, x2 minus x1 is written as delta x, t2 minus t1 is delta t, and this thing is called as what? Derivative of position with respect to time. So the instantaneous velocity is given by derivative of position with respect to time. Okay, instantaneous velocity is given by derivative of position with respect to time. All right, and what is the geometric meaning of derivative? It is slope of a tangent line. Geometric meaning is slope of a tangent line. Okay, so this is the formula. Instantaneous velocity is given by derivative of position with respect to time. All right, then if we come to the VT graph, velocity versus time graph, and similarly we know that just like velocity is change in position upon time, acceleration is change in velocity divided by time. And if you want instantaneous acceleration, always remember this: when you have separate times, okay, then the quantity that you are finding out, any quantity, maybe it's velocity, maybe it's acceleration, whatever it is the average value of that quantity, right? And if you want instantaneous value of quantity, what do? You just take derivative. Okay, so acceleration is change in velocity, v2 minus v1 divided by t2 minus t1. Okay, v2 minus v1 is written as delta v, t2 minus t1 is written as delta t. Instantaneous acceleration, the instantaneous acceleration is what? This delta t becomes very small, limit delta t tends to 0, delta v by delta t, and it is dv by dt, derivative of velocity with respect to time. Okay, this is clear, everyone? All right, good. So this is when you find out derivative, you get this thing. Okay, and then the next is area under the Vt graph. Okay, we know that area under the velocity versus time graph uses what? Displacement. Okay, area under the velocity versus time graph uses displacement. So what is displacement? It is just area under the velocity versus time graph, and the graph is simple one like this. Then finding out area is very simple. It's just this side multiplied by this side, right? But if you have a complicated graph like this one, then what you do is you break down this one, okay, this total interval into n number of small segments. Then you find out area of one such segment. So this is t1 to t2 is the interval. You break it into small segments and you find area of one segment. So what will be area of one segment? So you can say it is just v multiplied by the width of the segment, it's delta t, let's say. So v times delta t. Okay, or velocity at this point is suppose v1, velocity at this point it's v2. So you keep on doing this, v1 times delta t plus v2 times delta t, you will get this segment, area of this segment plus area of this segment plus area of this segment, so on and so forth. And you say that approximately that is equal to area under this curve. Okay, so approximately we say that it is equal to area under the curve, and this approximation will increase if we take, see here itself, you can see here the width of segment is this much, so you have this much of error. Okay, so the area that you are calculating is v1 times delta t, so it is this area, right? It is this area. So this blue shaded region is the error. Okay, you are counting that much less. This one, in this one, this is the error. Okay, so you are counting that much less, right? So this is the error, this is the error. So if you divide into n number of segments having width equal to this much, okay, and you are saying that area under the curve is area of all those segments, then you are committing some error, right? So it will be area of these small triangles. If you add up the area of all those small triangles, you will get the error. But then instead of taking this much width, if you take this much width, okay, smaller width, half of the width, then what will happen? So see, then area under the curve, you will approximate it to area of this segment plus area of this segment, and here you can see the error is reduced. Okay, this is the error now. So compared to this one, compared to this case, the error here is reduced, right? So if you divide the time interval into more number of segments, if you chop the time interval into larger number of segments, then what will happen? Error will be reduced. Then area under the curve will be approximately equal to sum of areas of all those segments. And how to do that? If you divide the time interval into small segment, means you will need to divide it into more number of segments. So number of segments will approach to infinity. Okay, so what is the displacement? It is sum of all these small areas, you can say. Okay, so that is v times delta t. Okay, v1 delta t plus v2 delta t. So sum of all those is written like this: summation I goes from 1 to n, vi times delta t, right? And then now if we take n very large, and we take very large, that means n tends to infinity, then we replace this summation symbol by the integration symbol. So what is integration? Integration is also sum only, right? It's a continuous sum. So where you have this segment divided into infinite number of, interval divided into infinite number of segments. Okay, so when number of segments becomes what? Infinity, then summation becomes an integration. Okay, and we had seen this in basic maths, that this is what, this thing is the fundamental theorem of calculus. What does the fundamental theorem of calculus say? That suppose v is equal to dx by dt. Okay, if v is equal to derivative of x, then if you integrate v, you get x2 minus x1. Okay, if you integrate v from t1 to t2, you will get what? x2 minus x1. Okay, so you recall this, right? You remember this? Okay, good. All right. So then similarly, so x2 minus x1 is the displacement. It's given by area under the velocity versus time curve, and now we'll remember it like this. So if you have a curve something like this, that means v is some function of time. And how will you find out the area under the curve? To find out area under the curve, what will you do is, you will just integrate this v from t1 to t2. Okay, how will you find out the area under the curve? You will just integrate v from t1 to t2. That will give you area under the curve. So area under vt curve gives displacement. That means displacement, or x2 minus x1, is just equal to integration of v dt from t1 to t2. Displacement is area under vt curve, means it is integral of velocity, right, from t1 to t2. Similarly, change in velocity is area under the acceleration time curve. That means that what is change in velocity? So change in velocity is integral from t1 to t2 of a dt, acceleration. Okay, it is integral of acceleration from t1 to t2, and dt is there just to show that the time is variable. Okay, this thing is clear, everyone? Right? And this thing, actually we have seen all of this in basic maths, but just recalling this, if h is equal to dg by dx, if h is derivative of x, then if you integrate h, what do you get? If you integrate h from x1 to x2, you get the value of g at x2 minus value of g at x1, right? So it simply means if h is derivative of g, then integration of h is derivative of g, then integration of h will give you what? It will give you g back. Okay, if a is derivative of b, then b is integral of a. That's the meaning. A is derivative of b, b is integral of a, right? All right, so this thing actually I have explained it. So area under the acceleration versus time graph, how will you find it out? Area under any graph, how will you find out? So this quantity, okay, you are plotting along the vertical axis, you want to find out area of this quantity, right? Area under the graph means, so you will write it like this, it is area of acceleration versus time graph, it is a times dt. Take the quantity on the vertical axis, that is a, take differential means delta t you can say, but we write it as dt here while taking integral. Okay, so take quantity on vertical axis, that is a, then what is quantity on time axis? It's horizontal axis, it's time. So here you will take a dt. Okay, quantity on vertical axis, quantity on horizontal axis, you will write it as d times that quantity. Okay, If it is time, then it is dt. If it is distance or position, then it is dx. And then you integrate it from initial time or whatever that quantity is to final time, so t1 to t2. So this area under acceleration versus time graph, what does it give? It gives us velocity, change in velocity, right? Velocity at final time minus velocity at some initial time t1. Okay, so tell me if there is a question in this, anyone? Do you have any question in this? All right, good. So I went a little bit fast because we have seen these topics in basic maths. All right. Okay, so this is similar question. Actually, I should have taken it along with those questions. Anyways, which of the following curve does not represent motion in one dimension? It's option B, right? All right, let's come over here. The displacement time graph of a moving particle is shown below. The instantaneous velocity of the particle is negative at the point. Where is it negative? So option A is E, right? Good. Yeah, everyone is saying option A, right? Option A means point E. So what is the velocity? It's slope of the displacement time graph or position time graph, you can say. So this point at point C, if you draw tangent to the graph, it's like this. So its slope is positive. That means velocity is positive. Okay, at point D, it is flat line. So it's horizontal to time axis, means at this point the velocity is 0. At this point the slope would be like this. So the velocity is, at this point the tangent drawn goes like this. So velocity would be negative because slope is negative, right? So option A is correct. All right, let's see next one. A particle shows distance time curve as given in this figure. The maximum instantaneous velocity of particle is around the point. Tell me. A particle shows distance time curve as shown like this. The maximum instantaneous velocity is at a point. This is A. Is it at A? Point B? Yeah, I am also thinking
Point
it's,
C.
you think it's point C? Okay, let's draw a tangent. First of all, they have not marked the points. So let's mark points. Will it be B? So, okay. So again, we are just trying to understand this. So I'm marking these points. Okay. So they have just written A, B, C, D. That doesn't mean anything. They should be points, right? Discrete points. Here you have point B. At A, it's not maximum. That is for sure. A is this point. Okay, at B, let's draw tangent at B. So this is tangent at B will look something like this. Tangent at C, yeah, tangent at point C will look like this, something like this. Okay, and tangent at point D will go something like this. So as I see, for me, it's the point C, right? Okay, yes, no, I think for point C it is more steep compared to point B also. Yeah, it's point C. right? Okay, convinced with me everyone? Okay, good. So it is point C. Point C means option D. Okay, all right. That was very simple question. Let's see next one. The points are marked. That is very simple question, right? And in NEET, points will be marked. Let's see next one. Two cars P and Q start from a point at same time in straight line and their positions are represented by xp of t is something, at plus bt square, and xq of t is equal to ft minus t square. At what time do the cars have same velocity? At what time their velocity is equal? This is the question. So tell me, velocity is equal, no? That is very simple. Just take velocity of first point vp is equal to velocity of second point. And what does that mean? If velocity is equal means what is given? Their position is given in terms of time, right? So dx for p by dt is equal to dxq by dt. Okay, now put the values, put the equations. D by dt of at plus bt square is equal to d by dt of ft minus t square, and now take the derivative. So that is, what is derivative of first one? Derivative of first one, a, this is at, derivative of that is just a, right? This one bt square, so b you can take out, derivative of t square is just 2 times t, and therefore it is 2 times t into b. Okay, so 2 times t, sorry, it's a plus 2 times bt, and that's equal to, take derivative on right hand side, so it is f minus 2t. Okay, and just move this on this side, so this becomes 2bt plus 2t is equal to f minus a, right? And you can take t common, and then there is nothing in the question. It is f minus a divided by, if you take t common from here, it's 2b plus 2, right? That is the answer, or it is f minus a, that's there in only one option, it's option D, f minus a, right? And in denominator you can take 2 also common, so it's b plus 1 or 1 plus b. Okay, so it is option D. This is very simple. Yes, everyone. Selva Kumar.
Clear, sir.
Right, Indusha.
Yes, sir.
Okay, good. Let's see next one. If the velocity of a particle is v equals to at plus bt square, where a and b are constants, then the distance traveled by it between 1 and 2 is. Okay, tell me, what should I do? I want to find out distance traveled. Tell me. Velocity is given, distance traveled. Yeah, take integration. It's very simple, right? Distance traveled between 1 second and 2 seconds. So displacement is equal to, actually it would be displacement, not the distance. Okay, and it will be at plus bt square dt, so that is velocity. Or let me write this thing first. Displacement is what? Area under vt curve from some initial time to final time, t1 to t2. Okay, and what is v? V is equal to at plus bt square. right? And what is initial and final time? The initial time is 1, final time is 2. Then that's simple. What is integration of t? So you have the formula, if you remember, integration of t raised to n dt is t raised to n plus 1 divided by n plus 1. Okay, power law of integration, right? It's option A. Let's check. So it is t square upon 2, right? Integration of t is t square by 2. This is t raised to 1, t raised to 1 plus 1 upon 1 plus 1, plus you have b, then it is integration of t square, it's t cube by 3. But then you need to apply the limits. Okay, so limits are 1, 2, 1, 2. Put the upper limit and then the lower limit. So x2 minus x1 is equal to a multiplied by upper limit. Okay, you can take that 2 also outside, right? You can take this 2 outside. So it's 2 square, you put 2 instead of t, so it is 2 square minus, then you put lower limit, so that's 1 square, 1 square is 1, plus b by 3 multiplied by, it is 2 cube minus 1 cube. Okay, so that is equal to this is 4 minus 1, so that's 3 by 2, 3 by 2 a, plus this is 8 minus 1, so 7 by 3, 7 by 3 b, right? So it is option A, right? Good, Vishalini. Okay, so this is clear, everyone? Okay, this is very, very simple. It is from NEET 2016. Okay. Oh, just 1 second. Let me erase this quickly. Yeah, I guess nobody was able to solve see the solution, right? I erased it very, very quickly. All right, so the displacement x in meter of a particle of mass m moving in one dimension under the action of a force is related to time t, is given by this thing. The displacement of particle when its velocity is 0 will be, tell me. You want displacement when velocity is 0. What will you do? What is given? T is equal to root of x plus 3, and I want the displacement of particle when velocity is 0. What should we do? So in order to find out velocity, okay, they are saying velocity is 0. First of all, what do you need to do? You know that velocity is 0 means dx by dt will be equal to 0, right? So first of all, you need x. So for that, find out x. Okay, so take that 3 on this side. You have t minus 3 is equal to root of x. Okay, square that. So you have x equal to t minus 3 square. So you got now the relation between x and t. Okay, x in terms of t, earlier t in terms of x was given, now you have x in terms of t. So just find out velocity. So what will be velocity? It is dx by dt, that is equal to derivative of this thing, right hand side, so d by dt of this thing, t minus 3 square. So without expanding this, can you tell me what's the derivative? Yeah, anyone? Without expanding.
2 into
2 into t minus 3, right? So okay, here we have used the chain rule. V is equal to 2 multiplied by t minus 3. Okay, So take the bracket, you have bracket square. Okay, so now just take derivative of the this thing, function of bracket. So it is 2 times the bracket multiplied by, take derivative of bracket. What is derivative of bracket? So inside bracket you just have t minus 3, so derivative of that is just 1. Okay, so that's why it is just 2 into t minus 3, right? This is the chain rule, remember everyone? Okay, all right, this was simple one. Sometimes you have some other functions, okay, then it's more useful, right? Okay, so then you got v and you want displacement at v is equal to 0, when v is equal to 0. So put v is equal to 0. So if v is 0 means t minus 3 is equal to 0. Yeah, t is equal to 3. So if t is equal to 3, put that in x. Okay, you want displacement when the velocity is 0. So x when t is equal to 3, because at t equals to 3 the velocity is 0. So that is 3 minus 3 square, right? So that is 0. So the answer is 0. Okay, this is simple. Yes, no, everyone? Simple, not simple? Okay, good. All right, let's see next one. So the questions now will be like this. Sometimes you have to take derivatives, sometimes integrals. The motion of a particle along a straight line is described by this equation. This is the equation where x is in meter and t in second. The retardation of the particle. So what does the retardation mean? It means negative acceleration. Okay, when its velocity becomes 0. So they put the condition, when the velocity becomes 0, find out the retardation. That's it. So first of all, find out the point at which velocity becomes 0. We have x equal to 8 plus 12t minus t cube. Okay, so then take dx by dt. V is equal to dx by dt, and that is equal to what? Take derivative of this thing. Derivative of 8 is 0. Derivative of this 12t is 12 minus derivative of t cube is 3t square, and you want it to be equal to 0, right? So first of all, you got the equation for v, and v is equal to 0 means 12 minus 3t square is equal to 0. So 3t square will be equal to 12. That is t square is 12 by 3. That means t square is equal to 4. So you got t square equal to 4. So you get two values of t. T is equal to plus or minus 2 seconds. Which one will you take? Plus 2 or minus 2?
Plus 2.
Right, it's plus 2. Okay, because time cannot run backwards. All right, so then just put that in the velocity, because you want to find out, no, you want to find out retardation when the velocity is 0. Sorry, so you want to find out retardation when the velocity is 0. So you have velocity, the equation for velocity, take that, find a is what? Dv by dt, right? Find out the acceleration, dv by dt. So that is d by dt of this thing, 12 minus 3t square. Okay, so that is derivative of 12 is 0, derivative of this thing 3t square, okay, it will be minus 6t. Okay, minus derivative of yeah, it's option D. Let's check. So 3t square is minus 6t, because derivative of t square is 2t, and you want it at t equal to, acceleration at t equal to 2. So that is minus 6 multiplied by 2, so that is minus 12 meters per second square. Okay, so the magnitude is 12, right? It's option D. Good. Okay, this is simple, right? Okay, let's see next one then. A particle moves along x-axis. The position x of a particle with respect to time from origin is given by x is equal to b naught plus b1t plus b2t square. The acceleration of the particle is, tell me. It's option D, 2b2. Good, very good. How did you solve? Yes, Yamini, how did you solve? Double derivative. Okay, 2 times. Okay, good. 2 times differential. Right. To find out acceleration, just find out d2x by dt square. So if you take dx by dt first, what do you get? That's d by dt of this thing, b naught plus b1t, okay, plus b2t square. Now I am explaining, so I have to write, but you can take derivatives in mind, right? So derivative of b naught is 0, then take derivative of this one, that will be b1 plus derivative of this thing. So b2 is a constant, so it will be 2 times b2t. So it is b1 plus 2 times b2t. Okay, then take another derivative. So if you take another derivative, d2x by dt square, so that is equal to, that will be equal to d by dt of this thing, b1 plus 2 times b2t, and then again this thing will be 0, derivative of this one is 2b2, and this is the acceleration, 2 times derivative of x with respect to time. Okay, that's good. Then see, if you have t square in the equation of x means position or displacement, then the acceleration would be, see, acceleration would be equal to 2 times the whatever term is there, right? If it is b2, it will be 2 times b2. Why is it so? Let me explain. Okay, you can just compare this one. So you can write this thing as x minus b naught is equal to b1t plus b2t square. So can you recall something? It resembles with some formula. S is equal to ut plus half at square, right? So that means u is equal to b1, okay, u is equal to b1, and a, half a is equal to b2. So if half a is equal to b2, means a is equal to 2 times b2. This thing is clear? Yes, no? Okay, so you don't even have to take two derivatives, because if you compare, you get two things immediately. You get the velocity, initial velocity, and also you get the acceleration. Okay, right. Just remember this thing, if x goes proportional to t square, okay, directly proportional to t square, or there is one term containing t, another term containing t square, then the acceleration would be what? The term multiplied, the coefficient of t square multiplied by 2. Okay, coefficient of t square multiplied by 2, right? So this is very, very simple. Okay, and if there is an equation like this, I mean x is proportional to t square, or there is some term containing t, some term containing t square, then this thing you can do, you can just compare it with s is equal to ut plus half at square to find out initial velocity as well as acceleration. Okay, all right. Okay, let's see next one. A particle moving along x-axis has acceleration f at time t given by this thing, where f0 and t are constants. F0 is constant, capital T is constant. The particle at time t equal to 0 has 0 velocity. So velocity is 0 when t is equal to 0, and if the time interval between t equal to 0 and instant when f is equal to 0, this thing is equal to 0, the particle's velocity is, okay, the particle's velocity is. So how do we find that? So what is this thing? What is f? It is an acceleration. The particle has an acceleration f, okay. So not a standard notation, but they wanted to take it like that, right? So how will you find out the velocity? You have v minus, we can say v2 minus v1, or vt minus v0 would be just equal to what? Integral of a dt from 0 to t, right? And they say that particle has zero velocity at the start, okay. It has zero velocity, means v0 is equal to 0 at the start. The velocity is 0, v0 is equal to 0. So v at time t is just equal to integral from 0 to t of a dt. So we need to take integral of this thing, but then we want what is this time t, okay. So for that they have given another condition, that f is equal to 0, the instant when f is equal to 0. So just take f is equal to 0. So f equal to 0 means f0 multiplied by 1 minus, okay, f0 times this thing is 0, 1 minus t by t is equal to 0, and that means if f0 is a constant, okay, it cannot be equal to 0. So 1 minus t by t is equal to 0, okay. 1 minus t by t is equal to 0, and therefore t by t is equal to 1 and t is equal to capital T, okay. So you got that. So small t is equal to capital T. So you got both limits. Initial limit is 0, final limit is capital T. So 0 to capital T, and what is acceleration? It is f0, right? f0 multiplied by 1 minus t by t. Just integrate that. It's very, very simple. Right? Okay, so let's integrate that. So f0 we can move outside. This is just f0 multiplied by integration of dt, okay. I'm just multiplying with this dt from 0 to capital T minus t by capital T, okay, integration of this thing from 0 to capital T. So take integral. So f0 will come in multiplication with this one also, okay. So integration of this thing is just t, and lower limit is 0, means it's meaningless, okay. So upper limit, you just have to put upper limit. So this is f0 times t minus f0 times, what's that, integration of t dt sorry, t dt would be t square by 2. You can take capital T outside, so it will be just t square by 2, okay. So you can cancel out this one, so it is f0 times t by 2. f0 t minus f0 times t by 2 means it is f0 times t by 2. So that's the answer. f0 times t minus, yeah, f0 times t by 2. So half of f0 into t. That's the answer. It is option D, right? Yes, no? This is slightly lengthy, but simple, right? Okay, so this is the answer. Let's see next one. A particle moves a distance x in time t according to equation this thing. The acceleration of the particle is proportional to. Now see the options. They say velocity raised to 3 by 2, distance raised to 2, distance raised to minus 2, velocity raised to 2 by 3. Okay. So what does it mean? It means that you need to find out the velocity as well as acceleration, both of them. Okay, but we'll anyways need to find out velocity also, because to find out acceleration we need to find out velocity first. So okay, what is velocity? It's dx by dt. Okay, that is equal to, what is your x? So t plus 5 raised to minus 1, take derivative of that. Tell me what's derivative of this thing? Using the power law. It's minus 1. What is derivative of this thing? Simple, no? Minus 1 multiplied by t plus 5 raised to minus 2. That's the derivative, right? And then you want to find out acceleration. What will be acceleration? It's dv by dt. Okay, dv by dt. So that is a is equal to d by dt of this thing, minus 1 multiplied by t plus 5 raised to minus 2. So that is minus 1 multiplied by minus 2 into t plus 5 raised to minus 2 minus 1, that is minus 3. That is 3 times t plus 5 raised to minus 3. And now you want to relate this one with either the distance or the velocity. So tell me. So velocity is proportional to t plus 5 raised to minus 2. Distance is proportional to t plus 5 raised to minus 1. You said something, Vishalini?
Multiplying acceleration power into 2 by 2, sir.
Multiplying that, yeah, you can do that. 2 by 2, right? So if you multiply that by 2 by 2, what will you get? 3 into t plus 5 raised to minus 3 by 2 into 2, or minus 2 into 3 by 2 you can say. And this thing is what? T plus 5 raised to minus 2. So it's proportional to velocity to the power 3 by 2. Yeah, that's correct. Not equal to, we can say proportional to v to the power 3 by 2. So that is the answer. It's option A. Okay, this is also simple, right? Okay, good. So this is just little bit of adjustment. Okay, but it's simple. Let's see next one. Yeah, tell me.
Sir, can you explain the last step?
This one?
Yes, sir.
So what you have done is you have multiplied this power by 2 and divided by 2, nothing else. Okay?
Okay, sir.
Because
Yes,
you
sir.
have velocity is equal to something, some constant multiplied by t plus 5 raised to minus 2. That means velocity is proportional to t plus 5 raised to minus 2. Okay? And in acceleration you have t plus 5 raised to minus 3. So to check its relation with velocity, you are bringing this thing, okay, t plus 5 raised to minus 2. How can you do that? So minus sign is already there. T plus 5 raised to minus 3 is there. You multiply with 2 and divide by 2. You have multiplied with 2 and divided by 2. So this thing is what? This thing is proportional to velocity. Okay, so this thing is proportional to velocity and you have power 3 by 2 of that. So therefore acceleration is proportional to v to the power of 3 by 2. Right?
Yes, sir.
Okay, that's simple. Alright, let's see next one. The position x of particle with respect to time along the x-axis is given by x is equal to 9t square minus t cube, where x is in meter and t in second. What will be the position of this particle when it achieves maximum speed along the x direction? Tell me. For the maximum speed, what do you need to do? You need to check. So v is equal to what? Dx by dt, right? So first of all, find out that v is equal to dx by dt. that means d by dt of 9t square minus t cube, derivative of that is 2 times 9 into t, okay, derivative of t square is 2t minus 3t square, that is 18t minus 3t square. This is velocity, and you want maximum speed, maximum velocity, okay. So what does that mean? It means that derivative of velocity would be equal to 0. Remember maxima minima, at the position of maxima, at the position of minima, the derivative of a quantity is equal to 0, right? So when velocity is maximum, what happens? If you plot the velocity versus time graph, if it goes something like this, let's say at maximum velocity, if you find out its slope of the graph, that is equal to 0, okay. So at Vmax, dv by dt would be equal to 0, and tell me what will be second derivative of v with respect to time? It will be positive, negative? Positive or negative? It has to be negative, right? At maxima, second derivative is negative. At minima, second derivative is positive. Okay? Yes, no, remember that, right? Okay, so at Vmax, dv by dt is equal to 0 and second derivative is negative. If it was minimum velocity, dv by dt is still 0, but second derivative would be positive. Okay. Alright, so let's check dv by dt. So dv by dt is equal to, take derivative of this thing, so it's 18 minus 60, right, and that should be equal to 0. That means 60 is equal to 18, or t is equal to 18 by 6 means 3 seconds. But then you got only one value, so you don't need to check the double derivative, right, because you got only one value. Okay, if you got two values, then you need to check the double derivative. Okay, and mostly will not get two values. Mostly I am saying, okay, there can be an exception. Mostly will just get one value where derivative would be equal to 0 in NEET. Okay, all right. So we want position when velocity is maximum. That means derivative of velocity is 0. So we got the time when this thing happens, t equal to 3 seconds. So position is equal to what? 9t square minus t cube. So put t equals to 3 there. So 9 times 3 square minus 3 cube. So that is this is 9, 81, 81 minus 27. How much is it? It's 54, right? Okay. This thing is clear? Yes, no?
Yes, sir.
Okay. So see, here also I have, okay, while doing this calculation, that's not very difficult. You can subtract it, but I have used a small trick. So let me just tell you, maybe it would be helpful to you. So I wanted to do 81 minus 27, right? So what I did, okay, what I did basically, so I subtracted 30 from 81, so I got 51. Okay, but I over subtracted by 3, so I added 3. So that's why it's 54. You got it? Yes, no? Okay, you can see that I was able to do that very quickly. So this is, I do these kind of tricks. Okay, so maybe it's helpful, it might be helpful to you also. Okay, it might save your 1 or 2 seconds. Every second is important, that's why. All right, good. Let's see next one. A particle is traveling along a straight line OX. The distance x in meter of particle from O at time t is given by this thing. where t is in second, the distance of particle from O when it comes to rest is? Tell me. So these are similar kind of problems, right? Distance of the particle from O when it comes to rest is. So this is simple. Just find dx by dt. It comes to rest means the velocity would be equal to 0. So d by dt of this thing 37 plus 27t minus t cube. Okay. So this thing is just 27 minus 3t square, because derivative of 37 would be equal to 0, and this is equal to 0 because particle comes to rest. So 27, so v is equal to 0 means 27 minus 3t square is 0. Okay, and that is 3t square is equal to 27. So t square is 9, so t is plus minus 3, we'll take plus 1, right? T is equal to 3, and you want distance from origin, so just put that over here. So you get x equal to 37 plus 27t minus t cube. So 37 plus 27 times 3 minus t cube is what? 3 cube. Okay, so this is 27 times 2. Okay, no, this is 27 times 3 only. Sorry, what am I saying? Okay, I calculated it first. So this is 27 and 3 minus 1, so it's 27 times 2. 27 times 2, that's 54. 54 plus 37. How much is 54 plus 37? 91, right? So the answer would be 91. Yeah. So x will be equal to 91 meters. Okay. But then this is simple. They said that what will be its distance from the origin. But if they say what will be its distance from the starting position, tell me what will be the distance from the starting position. Anyone? The distance from the starting position. Suppose this equation is given, tell me what's the starting position. Yeah, good, Yamini. That will be distance from the starting position. So starting position is 37, right? When you see this equation, x is equal to 37. Okay, this thing is starting position, right? You can compare this with x is equal to x naught plus some function of t. Okay, so this constant term is starting position. Remember that in the equation of x. Okay, in equation of position, the constant term, the term that doesn't contain time, is starting position. Okay, remember that. All right, so let's see this one. The acceleration of a particle is increasing linearly with t is as bt. The particle starts from origin with an initial velocity v0. The distance traveled by particle in time t will be. Okay, the distance traveled in time t will be. Tell me. Acceleration is given, right? Acceleration is given, a is equal to bt, and you want distance, so just double integrate that, right? So if you integrate this thing, a dt from 0 to t, what will you get? You will get v at time t. Okay, v minus v0, right? You will get v minus v0. Okay, so what is a? A is bt, so just integrate that. So bt dt, integration of that will give you what? B you can take outside, integration of t, just t square by 2, and lower limit is 0. It's option C. Okay, might be, let's check. So it is b times t square by 2, half of bt square. Okay, and then you want the distance sorry, the distance x minus x naught just equal to integration of v dt. So what will be v? Take that v naught on other side. Okay, so v is equal to v naught plus half bt square. Okay, you need to integrate that. So that is v naught times, okay, dt, v naught times t if you integrate this. Okay, and integration of this thing will be t square by 3. Yeah, so it is half of b times t square by, sorry, t cube by 3. I said t square, it will be t cube by 3. So 2 times 3 is 6. So bt cube by 6, v naught times t plus bt cube by 6. Yeah, so it is option C. Good, correct. So let us see few more problems. Let's see this one. The displacement of a particle starting from rest is given by s is equal to 6t square minus t cube. Okay, the time in second at which the particle will obtain zero velocity. Okay, so this is very simple. How do we solve this? Tell me. What will you do? You will just take derivative of this, right? Yes, no? Right, just take derivative of this. So when you take derivative of this, you will get v equals to ds by dt, that is d by dt of this thing 6t square minus t cube. Take its derivative, so it will be 6 times 2t minus 3t square. Okay, and you want that this velocity becomes 0. When does it become 0? So here you can take t common, so it is t multiplied by 12 minus 3t, right, and equate this to 0. Yeah, is it option B? Let's check. Okay, so t is equal to 0, this velocity is 0 either at t equal to 0, but they are not asking about that, right, because it's starting from rest only, and you have 3t minus 12 is equal to 0, that means t is equal to 4. So this is option B, that's correct, right? This is very simple. Okay, now then let's see this one. The particle moves along a straight line OX at time t. The distance x in meter of the particle from O is given by this thing. How long would the particle travel before coming to rest? So how will you solve this? How long does this particle travel before coming to rest? This is the question. So again we'll find out what dx by dt, and we'll put v is equal to 0. Yeah, we'll take derivative of this, v is equal to 0, right? So it will come to rest, then we'll find out that time, we'll put it in this formula, and we'll get the we'll get the time, right, and we'll put it in this formula so that we get its next position. Okay, so we have x is equal to 40 plus 12t minus t cube. Okay, let's take dx by dt, so that is 12 minus 3t square. Okay, and this is equal to 0, right? This is equal to 0, so this is equal to 0 means 3t square minus 12 is equal to 0, so 3t square is equal to 12, or t square is equal to 4 means t is equal to plus or minus 2, right? So we'll take plus 2 and put it in this formula. So we get x is equal to what? 40 plus 12 times plus 2 minus t cube. So that is 2 cube. Is it option A? Let's check. 2 cube. Okay, so this is 24 minus this is 8, 16, right? That's 16. Okay, so this is 40 plus 16. Okay, that's 56. But what is the starting position? Starting position is 40 and this is 56, right? If you put t equal to 0, so x at t equal to 0, what do we get? This term and this term becomes 0. So starting position is 40. This is 40 meters and when it comes to rest, it is at position of 56 meters. So you get 56 minus 40. So that is 16 meters. That is simple, right? This is also a simple question. Okay, all right. Then let's see this one. The position x of a particle with respect to time along the x-axis is given by this thing 9t square minus t cube, where x is in meters and t in seconds. What will be the position of particle when it achieves the maximum speed along the x direction? Okay, so what to do here? It attains the maximum speed along x direction. That means first of all we need to find out v. Okay, it's same as that of the earlier questions. Yeah, let's take derivative. So v is equal to dx by dt and that is equal to d by dt of 9t square minus t cube. Okay, but this is just velocity, right? So it will be 18t minus 3t square. So velocity is not 0, velocity is maximum. That means we need to take another derivative. What happens at the maximum velocity? So at maximum velocity, the change in velocity will become 0. So let's take another derivative. So when we take another derivative, so acceleration at maximum velocity, dv by dt would be equal to 0. And what is dv by dt? It's 18 minus 60. Okay, 18 minus 60. So that is, this thing is equal to 0 means t is equal to 3, right? This is equal to 0 means t is equal to 3. 60 is equal to 18, that is t is equal to 3, right? So what do we want? This is the time when velocity becomes maximum, because there is only one time. Okay, so as I said, most of the times we will not have to check for the second derivative of this, right? This is maximum because they are saying it's maximum. Okay, and if there are two times, then we need to check for the second derivative. So suppose there are two times t1 and t2 at which this thing becomes 0, then what will we do? We'll find out d2v by dt square. Okay, second derivative at t1, second derivative at t2. Okay, and we'll check which one is negative, because at maximum second derivative is negative. Okay, so then you put it here and again you want to find out the position, right? What is the position? So just put that over here. So you get x is equal to 9 times of t square, so that is 3 square minus 3 cube. So what's that? This is 81 minus, this is 3 3s are 9, 3s are 27. Okay, 81 minus 27, so that is 54. Okay, so this is also simple, right? Yes, no, this is simple. All right, then let's see next sum. A particle of unit mass undergoes one-dimensional motion such that its velocity varies according to v of x is equal to v of x raised to minus 2n. Okay, can you see this? v of x is equal to b of b multiplied by, not b, it's beta multiplied by x raised to minus 2n, where beta and n are constants and x is the position of particle. Beta and n are constants, x is the position of particle. The acceleration of the particle as a function of x is given by. So now what will you do? You are given v, which is function of x, so it is beta multiplied by x raised to minus 2n, and you want acceleration of the particle, again that too you want as a function of x. Tell me, what can we do? I want acceleration. What is acceleration? It is dv by dt, right? Acceleration is dv by dt, not dv by dt, right? Acceleration is dv by dt. So I want to take derivative of this right hand side with respect to time. Okay, that is beta x raised to minus 2n. But here this is not function of time, this is function of x, right? There is no t square, sine t, etc. here. It is x raised to minus 2n. So what can we do? Anyone? Okay, so what we'll do here is we'll use the chain rule, right? So please remember the chain rule. What can we do? We can use the chain rule, that is we are taking derivative with respect to time, but this is not function of time. So what we'll do is we'll take its derivative with respect to x only. Okay, so whatever it is, it's beta x, beta multiplied by x raised to minus 2n. Take its derivative with respect to x and then take derivative of x with respect to time, right? This is the chain rule. So you can say you have multiplied and divided by dx, right? Okay, good. Then take its derivative. What do you get? When you take its derivative, you will get a is equal to beta, you can take outside, then it's x raised to minus 2n, and your formula is, if you have x raised to n, its derivative is n x raised to n minus 1. Okay, so the power comes in multiplication, okay, and the power gets reduced by 1, so minus 2n minus 1, and then you have dx by dt. But what is dx by dt? What is dx by dt? Dx by dt is velocity. Okay, so you write that dx by dt is velocity, because dx by dt is v. Okay, and then what is v? V is given because we want everything in terms of x, so put v here. What do you get? You get a is equal to beta multiplied by minus 2n x raised to minus 2n minus 1 multiplied by v. What is v? V is beta x raised to minus 2n, right? So the final answer would be minus 2n beta square x to the power minus 2n means minus 4n minus 1. Okay, so that is beta square, okay, minus 2n beta square x raised to minus 2n is minus 4n minus 1. So this is the answer. It is option b square minus 2n, this is minus 4n, but they say it is e square. Here we have x to the power minus 4n minus 1. So this is the answer. This one is clear, everyone? Okay, good. Okay, so then we'll talk about the relative motion. Just a minute. Okay, so let's talk about the relative motion. Now what's that? It's the meaning is clear from the name itself. It is relative motion means you are comparing motion of one object with respect to another object. Okay, for an example, suppose there is the thief and a cop is also there. Okay, so in real life it's very difficult to happen, but suppose a thief is there and he snatches a chain from some woman and runs away, and cop watches that, immediately takes the action, and he also runs after him. Okay, so thief is running with some speed. Initially there is some distance between them, and for simplicity this is motion along a straight line. It's a straight road. Okay, so thief is running straight, cop is also chasing him. So now there is some distance between them, some initial distance between them. So SCT is relative distance between thief and cop. C for cop and T for the thief. Okay, it's the relative distance between thief and cop. So VC is the velocity of cop, VC is velocity of cop, VT is the velocity of thief, and the relative velocity of cop with respect to thief. The relative velocity of cop with respect to thief is given by what? VCT. It is VC minus VT. So relative velocity of first body with respect to the second body is equal to what? Velocity of first body minus velocity of second body. Okay, relative velocity of first body with respect to second body is just velocity of the first body minus velocity of second body. Okay, it's that simple. So then now see, he wants to cover this much distance. Okay, if thief was steady, then he could cover this much distance. We could say that this distance is just equal to what? Velocity of cop multiplied by time. But thief is not steady, he is also running away. He wants to save himself, right? So relative displacement is just equal to relative velocity multiplied by time. Okay, so this is the formula. Relative displacement is just equal to relative velocity multiplied by time. This thing is clear? Yes, no? Okay, now you might ask, how does it come? So the answer is very simple. See, the thief will run up to some distance, let's call it S suppose. Okay, so the distance covered by cop, distance covered by cop distance covered by cop is just equal to distance covered by thief, distance covered by thief plus cop has to cover this much extra distance, right? SCT. Okay, it's the initial distance between them. So then what is distance covered by cop? It is velocity of cop multiplied by time, and distance covered by thief would be velocity of thief multiplied by time. Okay, we are taking capital C and T for the cop and thief, capital C capital T plus SCT, and then you can move this thing on this side. So from that what do you get? VC, I will take T common, so VC minus VT multiplied by T is equal to what? SCT. Okay, and what is VC minus VT? It's velocity of cop minus velocity of thief. Okay, so velocity of cop minus velocity of thief is relative velocity of cop with respect to thief multiplied by time is SCT. Okay, so this is how it comes, right? What is SCT? Relative velocity of cop with respect to thief. It's equal to velocity of cop. What is SCT? The relative displacement to be covered by cop, okay, with respect to thief. So it is equal to the relative velocity multiplied by time. Okay, very simple formula. So now I have written it in terms of cop and thief, but it is applicable to any kind of relative motion between two objects. Okay, a relative motion with uniform velocity between two objects, not any kind, relative motion with uniform velocity between two objects. This is clear? Yes, no? Okay, good. Then we can think about uniformly accelerated relative motion. Okay, so initial velocity of cop is uc, initial velocity of thief is ut, acceleration of the cop is ac, acceleration of the thief is at. Then what will be the formula? So we can solve in the same way, okay, as that of before, and here we'll get sct would be equal to, just apply the formula ut plus half at square, just change u with the relative velocity and a with relative acceleration. Okay, just change u with the relative velocity, so it will be uct, okay, and a with acceleration, right, relative acceleration act. So this is clear? Yes, no? Everyone? Right, good. All right, so let's see a problem based upon this thing. So here I have explained it, how does it come, okay, but I guess it should be clear, right? If it is clear for uniform motion, it's clear for accelerated motion also. Okay, all right, so let's check a problem based upon this thing. A train of 150 meter length is going towards north direction at a speed of 10 meters per second. A parrot flies at the speed of 5 meters per second towards south direction, parallel to the railway track. The time taken by the parrot to cross the train is, tell me. There is a train which is moving towards north. This is the train. Okay, so there would be some velocity of train and the parrot is moving like this. Okay, so this is velocity of parrot. So time taken by parrot to cross the train is, anyone? Did somebody tell the answer? It's option D, right? It's option D. Okay, let's see how. So what is velocity of parrot? It is 5 meters per second. And velocity of the train, it's in opposite direction. So you will say velocity of train is equal to what? It's equal to what? It is equal to 10 meters per second, no? Oh, the parrot is very fast. But the train is moving in opposite direction. So it's minus 10 meters per second. Okay. And then how much distance the parrot has to cover with respect to the train? With respect to train, in order to cross the train, it's length of the train, right? So you can say length of the train or distance covered by parrot with respect to train will be equal to the relative velocity of parrot with respect to train multiplied by time, and therefore time is equal to SPT. Time is equal to SPT, okay, which is length of the train divided by VPT, and that is 150, right? It is 150 meters. And what is this thing? So this is equal to Vp minus Vt. So that's 5 minus minus 10. So that is 15, right? 5 plus 10. So 150 divided by 15 is 10. So therefore 10 seconds is the answer. That's very, very simple, right? Everyone? Okay, this is very simple. Yes, Indusha, this is simple. Yes, no?
Yes, sir.
Okay, good. Then let's see next one. A bus is moving with a speed of 10 meters per second on a straight road. A scooterist wishes to overtake the bus in 100 seconds. Okay, so a scooterist has a target also. He wants to overtake the bus and he wants to overtake it in 100 seconds. Nothing more than that. Okay, so if the bus is at distance of 1 kilometer from the scooterist, with what speed should the scooterist chase the bus? Tell me. Bus is moving with the speed of 10 meters per second on a straight road. Scooterist wishes to overtake the bus in 100 seconds. Okay, and initial distance between them is 1 kilometer. With what speed the scooterist should chase the bus? Again, you can say, suppose Vs is the velocity of scooterist. Okay, or speed of scooterist, and Vb is the speed of bus, right? Then you want relative distance of scooterist with respect to bus is 1 kilometer, right? So you can write that as relative velocity of scooterist with respect to bus into the time. Okay, so just put the values over there. So what is the relative distance to be covered? It's 1 kilometer. Okay, so scooterist is 1 kilometer behind. That is 1 into 10 raised to 3 in meters, right? And then velocity of scooterist with respect to bus is velocity of scooterist minus velocity of bus into the time is given. How much is the time? Time is 100 seconds. Okay, so then take that 100 on other side. Take the 100 on other side. So what do we get? Vs minus Vb is equal to 10 raised to 3 by 10. So that is 10. And now take Vb on other side. So what is Vb? It's 10. So Vs minus 10 is equal to 10. So Vs is equal to 10 plus 10 means 20 meters per second. So this is the answer, right? It is simple, very, very simple. Okay, so scooterist must be NEET or JEE aspirant, right? Because he has a target 100 seconds. Okay, but we want to solve it in 60 seconds. Anyways, so this is clear, everyone. Selva Kumar?
Clear, sir.
Okay, good. Let's see next one. Preeti reached the metro station. Preeti reached the metro station and found that the escalator was not working. She walked up the stationary escalator in time t1. On other days, if she remains stationary on the moving escalator, on other days, then the escalator takes her up in time t2. The time taken by her to walk up on the moving escalator will be, tell me. So option B, t1 t2 divided by t1 plus t2. Okay, how did you solve?
Taking net velocity of the both.
Okay, so take velocity of both of them. Okay, so Preeti reached the metro station and found that the escalator was not working. Escalator is not working. She walked up the stationary escalator in time t1. So suppose length of the escalator is s. Okay, or let's take d. D is the distance to be traveled, length of escalator. Okay, so what will be velocity of Preeti? It will be d by the time taken by her, d by t1, right? On other days, if she remains stationary on moving escalator, then the escalator takes her up in time t2. So velocity of escalator is equal to d by t2, you can say, right? And then time taken by her to walk on the moving escalator will be. So now escalator is moving and she is also moving in the same direction, right? This is the escalator, it's moving in this direction. Preeti is also moving in the same direction. Okay, so now see, if Preeti is steady on the escalator, what is her velocity? Okay, so distance to be covered is this much. What is her velocity? Her velocity is already the velocity of escalator. Okay, so here when Preeti is walking on the escalator, what will be her velocity? Her velocity will be velocity of escalator plus her own velocity, okay, walking velocity, right? So now the velocity is equal to, v is equal to v of Preeti plus velocity of escalator. Okay, and so this distance is equal to, you can say it's equal to velocity multiplied by time. So this is equal to, what can you say, what is the velocity? It's velocity of Preeti plus velocity of escalator, that is equal to Vp plus Ve multiplied by t, and then you can put the values, right? What is Vp? It is d by t1. What is Ve? It's d by t2. So you can cancel out d, and then you can move this thing on other side and you can find out t. So what is t? So t is, if you take it on other side, 1 upon 1 by t1 plus 1 by t2, right? Then if you simplify this, what will you get? So if you do cross multiplication, here you will get t2, here you will get t1, and in denominator t1 t2, that will be in denominator of denominator. Okay, what I am saying is you need to multiply this term by t2, this term by t1. Okay, so if you multiply this one with t2, then this term will become t2, 1 will become t2 here. The denominator is t1 t2, right? This is t2, okay, plus t1, and denominator is in denominator of denominator. Okay, it's in denominator of this denominator, so you move it up, right? So it will be t1 t2 divided by t1 plus t2. So this one is clear? Yes, no? Everyone? Okay, good. Okay, so then now see, relative velocity is very nice concept. Okay, so some questions will be there in motion in a plane also, we'll see them. Okay, but as far as motion in a straight line is concerned, they didn't ask many questions in NEET. Okay, but they can ask, right? Now what we'll do is, so motion in a straight line we'll declare as done, and we'll move on to the next chapter, right?